Hello there, and welcome back to this quiet corner where curiosity and calm coexist, where the mysteries of the cosmos unfold slowly, one breath at a time. Tonight, we're not looking at galaxies far away or the birth of stars. Instead, we're turning our gaze towards something closer, stranger, and perhaps a little unsettling. We're talking about 3I Atlas, a visitor from deep interstellar space, and the newest data that suggests something about it doesn't quite add up. Imagine standing under a night sky so clear the stars look like they're whispering. Somewhere out there, past Pluto, a faint traveler drifts a long, tumbling object moving faster than any comet we've seen, on a path that doesn't fit the math. The telescopes call it 3I Atlas, the third confirmed interstellar object ever detected. But the new observations, they whisper of an anomaly, one so large, so peculiar, it's left even the quietest scientists awake at night, staring at their data and muttering, "That shouldn't be possible." Maybe you're listening late, the hum of the room around you, soft and steady. Maybe it's night where you are, screens dimmed, thoughts slowing down. Funny, isn't it? We're about to wander through light years and equations, yet we share this same little moment, separated by space, but connected by curiosity. Before we drift deeper, I'd love to know where in the world you are tonight, and what time is it there? Drop a comment if you'd like. Not for engagement, just as a kind of beacon in the dark, a sign that somewhere out there, another mind is wandering with you. So go ahead, get comfortable, dim the lights, let the day slip away. And while you do, consider this. What if an object from another star system wasn't just a rock or a comet, but something else? What if it moved in ways that defy what gravity should allow? What if its surface reflected light like metal instead of ice? And what if its path, its impossible, elegant path, was not random at all? No, we're not saying alien probe, at least not yet. We're saying something stranger, that the universe may be far more complicated than we've given it credit for. Because 3I Atlas is doing something the textbooks didn't prepare us for. And so, before we see what this interstellar traveler might be, we need to go back to where it came from, how it moved, and what the silence of space might be trying to tell us. Let's start right, where every good cosmic mystery begins with someone, somewhere, noticing a tiny piece of sky behaving badly. It began with a faint streak of light. In February 2025, astronomers at the Atlas survey in Hawaii noticed something that didn't move like a comet, didn't orbit like an asteroid, and didn't belong to our solar system at all. They named it 3I Atlas, the 3I meaning third interstellar. Within hours, observatories around the world were trying to catch its trail before it slipped away forever. You would have missed it if you'd blinked. A grain of brightness gliding against the static night, the kind of flicker you might dismiss as a plane, or maybe a cosmic eyelash falling across your telescope. But this one refused to stay ordinary. It slid through the star field with a confidence that felt almost rude, as if the sky had just been photobombed by another galaxy. Stars whisper, planets spin, comets fade, and return again. That's rhyme one, a small lullaby the sky hums while it works. You can imagine the telescopes humming along too, their domes creaking as they turned, metal muscles stretching under Hawaiian humidity. Inside, coffee-powered scientists squinted at screens that glowed blue against the black. Light on glass, time will pass, numbers bloom like frozen grass. The data arrived as columns of digits, each one a heartbeat from deep space. You, standing there in your imagination, can feel how cold those numbers are, distant but alive, like the sound of snow landing on metal. They plotted the object's course and realized it wasn't bound to the Sunday. That single fact made everyone sit up a little straighter. To wander in from interstellar space means surviving centuries of radiation, dust, and gravity wells. It means being older than any human language. It means, in a very literal way, that you just received mail from another star system. Dust and flame, without a name, the universe plays its quiet game. The astronomers began to joke nervously. They always do, when physics goes sideways. Someone suggested calling it a cosmic delivery error. Another said, maybe it was just the universe checking in, the way an ex-planet might peek through the blinds to see how you're doing. At home, the news barely made a ripple. You might have scrolled past the headline between videos of dogs in pajamas and people reviewing toaster ovens. But up in those domes, excitement had weight. The air itself felt charged, humming with the kind of energy you only feel when reality stretches a little further than you expected. Silver sky, questions fly, wonder hums as sensors sigh. That's rhyme 4, by the way. The night was beginning to taste like anticipation, dry, electric, a hint of burnt coffee grounds and cosmic dust. The object's speed didn't match anything familiar. It tore through the solar system at more than 50 kilometers per second, fast enough to outrun guilt, deadlines, and most known celestial etiquette. Its path was hyperbolic, meaning it came, waved politely, and would never return. Astronomers love a good tragedy, and this one was sprinting toward the exit. Fast and small, no sound at all, slipping past the cosmic wall. The great my franged to the Kim, the raided wise. Every telescope turned its eye toward it. Mauna Kea, Palomar, even backyard setups buzzing with amateur pride. Together, they built a kind of global heartbeat. Light in, data out, humanity blinking in synchronization. When the first images were stitched together, they showed nothing more than a blurry seed of light. Yet the pattern of its brightness told a secret. The object was rotating unevenly, like a badly thrown football or an ancient coin flipping through eternity. Each turn reflected sunlight differently, creating a pulse that felt alive. Spin and gleam, cosmic dream, caught between the light and scheme. You can almost hear the universe chuckle softly, as if enjoying the confusion. The scientists argued over shape, cigar, pancake, frisbee, banana, as if describing breakfast foods could solve astrophysics. The truth was simpler and stranger. Whatever 3i Atlas was, it was smooth, reflective, and far lighter than rock should be. Some suspected gas jets, others whispered about thin metallic structures. The data refused to choose sides. Thin as lace, through endless space, time itself begins to trace. Halfway through the observation window, the object brightened unexpectedly. A shimmer, a wink, instruments twitched. For a moment, one astronomer swore it changed direction ever so slightly. Probably nothing, she said. That phrase, as always, marked the beginning of obsession. Bright and near, gone and clear. Whispers only scientists hear. Soon, the weather turned. Clouds rolled over Hawaii. The telescopes went blind, and the object drifted beyond reach. In the control room, monitors dimmed to a quiet blue. The excitement cooled into that peculiar scientific melancholy, the kind that tastes like both success and loss. You imagine the scientists standing outside after sunrise, watching light spill across dormant volcanoes. The sky looked empty again, as if nothing had happened. But they knew better. They'd seen a visitor pass through one that refused to behave, one that carried mystery like perfume. Gone too soon, Under fading moon, silence hums a gentle tune. That's rhyme 9, sliding quietly between caffeine and awe. And finally, eyes to sky, we ask why. Stars reply with soft goodbye. The 10th rhyme closes the loop, leaving you exactly where you began. Small, curious, and slightly amused that reality still surprises you. So, breathe out, let your shoulders drop, and feel that wide hush of interstellar distance. Because 3I Atlas was only the beginning, a cosmic breadcrumb leading somewhere stranger. And as you drift in this soft orbit of thought, remember, even the smallest streak of light can change the way an entire planet dreams. Let's follow that faint streak of light as it slips past the sun's reach, like a whisper ignoring the rules of the room. Most objects that pass the sun trace neat ellipses, the predictable dance of gravity. 3I Atlas, however, wasn't following any ellipse. Its trajectory was hyperbolic, meaning it came from nowhere we could name, and it wasn't coming back. It entered our system like a message with no return address. You watch it glide through imagination, a spark defying choreography. Every planet in our solar family loops in patient circles, repeating itself like a well-rehearsed bedtime story. But this wayward guest tore straight through the narrative, ignored the punctuation, and left scientists clutching their coffee mugs like priests who'd just seen a ghost blink. Picture it now, a long, quiet traveler moving through the ink of space. The sun, enormous and golden, tries its best gravity trick, bending the surrounding fabric like a spoon in hot tea. Most guests stop to dance, comets swoop in, heat up, put on a show, and obediently retreat. 3I Atlas just kept going, tailless and unapologetic, as if it had somewhere better to be. You can almost feel that arrogance, the faint hum of indifference, a cosmic no thanks to every gravitational handshake extended its way. Its orbit wasn't a loop, it was an open door. Hyperbolic means freedom. It means once you pass through, there's no encore, no re-entry, no see you in 10,000 years. For the astronomers watching, that was equal parts thrilling and heartbreaking. They were witnessing a one-time show, the kind of thing you can't schedule again. They joked softly that the universe had ghosted them. But deep down, you know the truth. They were in love. Because when something truly new crosses your sky, even scientists fall a little bit in awe. The data told them it came from the direction of the constellation Lynx, a quiet patch of northern sky without any famous landmarks. No bustling star nurseries, no explosive supernovas, just stillness. That made its origin even stranger. There was no obvious birthplace, no comet family it could belong to. It was as if it had slipped through a crack between stories. And you, hearing this now, might wonder how far does a thing travel before it forgets where it started? How long until home becomes somewhere back there? Scientists calculated that 3I Atlas had probably been drifting for millions, maybe billions, of years. It had crossed entire spiral arms of the Milky Way, weaving between suns like a silent seed on galactic wind. By the time it brushed past our sun, it was already older than the continents beneath your feet. That's the scale we're working with. Time so large, it starts to sound like myth. The Earth itself has barely been around for a third of the journey 3I Atlas might have taken. It's as if the universe tossed a bottle into its own ocean long before there were humans to invent curiosity, and we just happened to be standing on the shore when it washed by. The funny thing is, even at 50 kilometers per second, space is too big for speed to feel impressive. Out there, momentum is a lullaby. Everything moves forever because there's nothing to stop it. You can almost imagine the object humming as it goes, a steady vibration of metal, ice, or something in between, pressing through darkness older than language. It passed Mercury without a nod, brushed past Venus, skimmed Earth's orbit just far enough to avoid headlines, and then slipped beyond Mars. Each planet watched silently, caught in their own ellipses, like dinner guests watching someone leave mid-conversation. No one followed. Gravity tried, failed, and gave up politely. The sun's light flared across its surface one last time, scattering off whatever material made it shimmer. Maybe ice crystals, maybe metallic dust, maybe something not yet in our textbooks. For a few hours, it outshone most of the background stars, a final flicker before vanishing into night. You can imagine the astronomers refreshing their data feeds, waiting for another detection. Nothing. The signal dimmed. The object receded. And in that silence, a new question took shape. How many of these have we missed? How many silent visitors drifted through before telescopes were invented? Before humans even noticed the sky was full of stories? The numbers suggest thousands every year, most too small or too faint to see. The galaxy, it turns out, is a constant exchange of debris, like a cosmic trade route where every star system occasionally loses something to the void. 3. Atlas was just the first one polite enough to introduce itself. Its hyperbolic path means it will keep traveling forever, unless it meets another star strong enough to curve its fate. But for now, it's leaving us, accelerating infinitesimally, carrying the sunlight it borrowed as a souvenir. You picture it fading smaller, dimmer, colder, until it's just a rumor of motion against the black. And still, the idea lingers. Somewhere out there, far beyond Neptune's frozen wake, 3I Atlas is still gliding unbothered, untethered, unsupervised. You can almost hear it hum if you listen between heartbeats. A visitor from nowhere, heading toward everywhere, leaving us with nothing but wonder and a few kilobytes of light. So for tonight, just let it drift through your thoughts. Imagine that impossible path looping gently across your dreams. And know this, even in the quietest corners of the cosmos, the unknown still finds ways to say hello, then quietly, beautifully, not look back. Let's turn our attention now to the part where science does what it always does best: panic quietly behind spreadsheets. When the first light curves came in, astronomers frowned. The object's brightness fluctuated wildly, implying it wasn't round. Some thought it was cigar-shaped, others said pancake flat. But the pattern didn't fit either. Whatever it was, it rotated like no rock we'd ever seen. You can picture the scene: a small, air-conditioned control room humming with caffeine and confusion, monitors flickering with lines of data that looked like someone's heart monitor after 3 espresso shots. Every few seconds, a new blip appeared, brighter, dimmer, brighter again. It wasn't just rotating, it was performing. Normally, a comet or asteroid twirls in predictable rhythm, like a sleepy dancer. 3I Atlas was more like a disco ball, on existential crisis mode. Its reflections hit sensors in sharp flashes, then vanished abruptly. "It's not rolling," one researcher muttered. "It's tumbling." That word tumbling carries a particular kind of dread in astronomy. It means unpredictability. It means the object isn't obeying neat math, and that makes physicists itch. You'd think describing the shape of a rock would be simple. It isn't. When you're billions of kilometers away, you don't see the rock itself, you see its light. You watch how the brightness changes as it spins, and then try to reverse engineer geometry from those changes. It's a bit like trying to guess the shape of a cat by watching the shadow it casts on a moving ceiling fan. The early light curve graphs looked absurd. Sharp peaks, Steep drops. No symmetry at all. The room buzzed with theories. "It's long," said one. "It's flat," said another. "It's possibly both," said a third, whose coffee was now 80% despair. If you were standing outside with a telescope that night, you'd see nothing more than a twinkle lost among stars. But through those enormous lenses, the twinkle became a mystery. The flashes were too rapid for a long cylinder, too uneven for a disk. One simulation rendered it as a shard, something jagged and fractured, like a chunk torn from a shattered mirror. Another modeled it as a hollow sheet, spinning like a leaf caught in an invisible current. What made it stranger was the rhythm of that spin. The object didn't repeat itself cleanly. Its light rose and fell with irregular grace, chaotic, but not random, like jazz. You could almost imagine it humming in syncopation, a cosmic Miles Davis improvising on gravity. At one point, someone proposed it was shaped like a Dorito. Equally possible, the lead astronomer sighed, and equally disappointing. The idea spread anyway, the internet adored it. Hashtags were born. People joked that the universe had flung us a giant snack to remind us who's really in charge of the pantry. But in the quiet corners of those labs, something more serious settled in. Objects don't tumble that way unless something unusual has happened to them. Maybe it was a fragment, a broken piece of a larger structure. Maybe it had been through a collision so violent that it was left spinning forever, like a cracked top with no hand to stop it. Or maybe, and here's where things got speculative, maybe its shape wasn't an accident at all. After all, a thin, irregular form could maximize radiation pressure sunlight, pushing gently on its surface like a breeze on a sail. That same pressure could explain its odd acceleration. So the thought emerged, unspoken at first. What if 3i Atlas was designed that way? Not by us, not by anything we know, but by physics itself. Designed by survival, a shape honed over eons. Not by tools, but by the quiet sculpting of time. You imagine it drifting through space, battered by micrometeoroids, scorched by cosmic rays, eroded until only the most aerodynamic version of itself remained, like a pebble smoothed by a billion tides, except the tides were made of light. That's the poetic version. The truth might be uglier, and therefore more interesting. A jagged splinter torn from an ancient comet, baked, spun, reshaped, until it resembled something alien purely by accident. Nature, after all, loves coincidence. Still, the pattern persisted. Every night, the same impossible light curve. You could almost hear the astronomers bargaining with the cosmos. Just pick a shape, they pleaded. Any shape. But 3i Atlas refused. It remained the celestial equivalent of shrugging. At some point, the team decided to run computer models around the clock. The simulations filled entire servers with hypothetical versions of the object, digital ghosts of possible forms. Long ones, flat ones, hollow ones, ones shaped like bent spoons or unfolded paper. Not one matched perfectly. The real 3i Atlas sat outside the boundaries of all expectation, and you, lying there listening, can feel why that matters. Because when the universe hands you something that doesn't fit, it's not a mistake, it's an invitation, a reminder that nature's imagination is still bigger than ours. The last telescope to catch its light recorded a flicker so erratic that one observer laughed out loud. "It's taunting us," she said. Maybe it was. Or maybe it was just sunlight bouncing off geometry too strange for our tidy metaphors. Either way, it was beautiful. So breathe in that image, a shard of light, tumbling endlessly between stars. Neither cigar nor pancake, nor anything we have a word for. It spins in silence, indifferent to categories, perfect in its refusal to explain itself. And as it vanishes once again into the dark, you realize the shape problem isn't really a problem at all. It's the universe's way of saying, stop guessing, just look. Let's drift back for a moment, not in space, but in memory. Because the story of 3I Atlas didn't begin with its discovery. It began years earlier, with another uninvited guest that left scientists blinking like owls in fluorescent light. Years earlier, another interstellar object, Oumuamua, had baffled scientists in much the same way. It too moved oddly, spun unpredictably, and reflected too much light. 3I Atlas seemed like its younger cousin, but louder, brighter, and carrying even more questions in its wake. Oumuamua, Hawaiian for scout or messenger from afar, arrived in 2017 like a polite alien knocking on the door of our solar system, then leaving before we could find the keys. It came from the direction of Lyra, the constellation of the harp, as if the universe itself were plucking a single strange note to get our attention. It passed through the inner solar system in a matter of weeks, never to return. You imagine the astronomers staring at their monitors, the way you might stare at your phone after receiving a message from an unknown number, fascinated, nervous, and slightly flattered. It wasn't just its speed or shape that unsettled them, it was its attitude. Oumuamua behaved like a rock that had read too much science fiction and decided to start freelancing. It was small, elongated, and oddly shiny, more reflective than expected, for an object that had spent millions of years marinating in cosmic radiation. It had no tail, no plume of gas or dust like a normal comet. And yet, as it passed the sun, it subtly accelerated, just enough to break the math. That tiny nudge shouldn't have been possible without gas jets or solar sails or, as one scientist joked, a mild sense of drama. Then Resalvdes, the fatherments the out for Grom, the king rather round of the pursed. Of course, everyone denied being excited. Astronomers are professionals at pretending not to have goosebumps. They wrote papers, gave interviews, and said things like, "We're not saying it's artificial, but we're not saying it." The tabloids, however, had no such restraint. Within days, headlines screamed that aliens had sent a probe. Memes erupted. A coffee company even released a "Welcome Oumuamua" blend promising flavor, not of this earth. But amid the noise, there was something deeper. Oumuamua was the first confirmed interstellar visitor in recorded human history, a literal messenger from another star system. For the first time, we could study a piece of another world without leaving home. That was enough to keep people awake at night, staring at ceilings, wondering what it meant. And then, it was gone. Too faint, too far, too fast. The data we collected were incomplete, like a photograph taken mid-blink. The scientists built models, debated endlessly, and disagreed about everything except one fact. Oumuamua was weird, the kind of weird that leaves fingerprints on your thoughts. So when 3I Atlas arrived, it wasn't just a new discovery. It was déjà vu. The same eerie, shape-shifting light patterns, the same odd acceleration, the same feeling that something had wandered into our cosmic living room unannounced. This time, though, astronomers were ready emotionally. At least, the telescopes turned faster, the data poured in, and yet the mystery deepened. It was as though the universe had said, "You wanted a sequel? Fine, but this one's going to be harder." Oumuamua's shadow lingered in every conversation. Every curve of 3I Atlas's orbit was compared. Every flicker of brightness cross-checked. Some even speculated that the two objects were related fragments from a single ancient event, scattered across the stars like crumbs from a cosmic accident. You picture it, An explosion long ago in some distant system, maybe a shattered planet or a dying star flinging debris into the void. Two shards, one large, one small, set adrift for millions of years, until fate, or geometry, brought them both through our neighborhood. It sounds poetic, which is why scientists hate it. But secretly, they love it. The truth is, astronomy thrives on repetition, patterns in chaos, echoes across time. That's what makes the déjà vu so delicious. Because each visitor adds another puzzle piece, not just to the story of interstellar wanderers, but to our own sense of cosmic context. The idea that our solar system is not a sealed bubble, but a rest stop on the galactic highway. There's something humbling about that. You, sitting here, warm and grounded, listening to this. Your atoms were forged in stars that once drifted between systems too. You are, quite literally, made of visitors. So when 3i Atlas arrived, maybe it wasn't just an echo of Oumuamua. Maybe it was the universe reminding us that we, too, are the echo of something older. Still, Oumuamua left scars on astronomy's collective mind. The debates never ended. Was it a comet, shedding invisible gas, a chunk of hydrogen ice, vaporizing silently, a fragment of a shattered planet, or, as one scientist phrased it with academic precision, a thing that refuses to tell us what it is? The rection so for Roman mine refit. You know have never lever the stick it. In that sense, Oumuamua was less an object and more a mirror reflecting our need to explain, to categorize, to name. It forced humanity to confront how little we know and how eager we are to fill that silence with meaning. 3i Atlas, brighter and brash, only widened that silence. And as it passed, you could almost imagine Oumuamua's ghost trailing behind it, a faint shimmer, an echo saying, "You still don't get it, do you?" Because maybe the universe isn't sending us messages at all. Maybe it's just doing what it always does, throwing stones across infinity, waiting to see who notices the ripples. So let the déjà vu settle in. 2 visitors, 2 mysteries, 1 recurring lesson. The cosmos doesn't repeat itself out of habit. It repeats itself out of patience. And every time we think we've solved it, it smiles, tosses another riddle through the dark, and whispers, "Try again." Let's talk about speed, the kind that makes even the universe raise an eyebrow. 3i Atlas entered our solar system at over 50 kilometers per second. Fast, but not too fast to be natural. Yet as it left, it didn't decelerate the way comets do after losing gas. Instead, it seemed to accelerate slightly, a whisper of motion that shouldn't be there. Now, to most people, 50 kilometers per second sounds impressive, but in the cosmic context, that's the interstellar equivalent of briskly walking into a meeting 5 minutes late and pretending you meant to. Still, the number mattered, because it didn't just come in fast, it left faster. Astronomers don't like things that get faster for no reason. Acceleration means force, and force means physics. And physics means someone should be able to explain it without shrugging. Yet here they were again, staring at data that refused to obey Newton like a rebellious teenager. Picture it, a long object tumbling through sunlight, shedding no gas, no dust, no plume, no polite comet tail to say, "Yes, I'm melting, please ignore the steam." Instead, 3i Atlas stayed cold, silent, and if you believe the instruments, just slightly smug. As it drifted away from the sun, it gained speed, as though being pulled by an invisible leash tied to something far beyond. The team ran simulations until their computers began to sound like overworked air purifiers. They ruled out gravitational interactions, No nearby planets had given it a nudge. They ruled out outgassing. There were no chemical signatures to suggest it was venting anything. They even considered whether the sun's own solar wind had given it a push. But the math didn't add up. You can imagine one astronomer leaning back in their chair, muttering, maybe it just wanted to leave. Everyone laughed nervously. Because in science, jokes are how you hide the feeling that reality is teasing you. This was not the first time the cosmos had played this trick. Oumuamua, that earlier visitor, had shown the same peculiar boost on its way out. But this time, the effect was stronger, clearer, undeniable. 3I Atlas was accelerating in defiance of frictionless logic. Now, for a moment, imagine being that object. You are 3I Atlas, born from a chaos no one remembers, drifting in endless night. You've been weightless for 1 billion years, and suddenly, you find yourself inside a solar system that bathes you in light and heat. The warmth touches your surface, molecules expand, metals shimmer, photons kiss your edges, and you lean ever so slightly into that touch. That's one theory. Anyway, radiation pressure, the idea that sunlight itself, gentle, patient, relentless, could push an object through space, each photon carrying momentum, striking like invisible snowflakes, nudging it faster and faster until it escapes the sun's reach. But there's a catch. For that to work, 3I Atlas would need to be incredibly light, thinner than aluminum foil, a cosmic wafer. Imagine something tens of meters across but no thicker than a sheet of paper, fragile enough to crumple in your hand, yet strong enough to cross the void. That's not a rock, that's a sail. The notion of a light sail, an object propelled purely by starlight, isn't new. Humans have built prototypes, and somewhere out there, our own thin sails drift through darkness, powered by the sun's breath. But seeing something like that arrive from another star, that's where speculation starts whispering in the hallways of observatories. Of course, no one dared print the word artificial, not in the serious journals. Instead, they used careful language, unexplained acceleration, non-gravitational force, photometric anomalies. Translation: we have no idea what's happening, but it's fascinating and slightly terrifying. The beauty of science is that even the unexplained has structure. The equations describing 3I Atlas's motion still worked. They just didn't know why they worked. Each night, the data showed a pattern so subtle it could almost be biological. A steady heartbeat in the graphs, a soft rise and fall that seemed too deliberate to be random. You, listening now, might feel a familiar tingle, that combination of awe and unease that comes from realizing how small we are in all this. Because it's one thing to look up and feel insignificant. It's another to realize the universe occasionally returns your gaze. Back in Hawaii, one of the Atlas researchers scribbled something in their notebook. Speed is a signature. Maybe, they thought, every celestial object carries its own rhythm, a tempo set by where it was born, how it lived, what forces shaped it. Maybe this one's rhythm just happens to sound like jazz. They tried to catch it one last time, telescopes swinging to track it as it faded beyond Mars, then Jupiter, then the outer dark. The numbers kept climbing, gently, persistently, as though 3I Atlas was exhaling light itself. No gas, no propulsion, just motion without apology. And then, one morning, the data feed went flat. The object was gone, too faint to see, too far to follow. The acceleration had ceased, not because it slowed, but because we stopped watching. In the quiet that followed, a question lingered in every observatory, every lab, every late-night thought. Was that acceleration an accident, or a message. Because in a universe ruled by predictable orbits, there's something deeply human about an object that refuses to slow down. So tonight, as you lie still, think of it racing into the dark, a sliver of light, outrunning curiosity itself. Maybe it's natural, maybe not. But either way, it reminds us of something quietly profound. Even in a clockwork universe, not everything keeps time. Let's dim the lights a little because this next part is all about the way something shines when it shouldn't. Its light wasn't consistent with ice or rock. Some wavelengths reflected as though off-polished metal. Some suggested thin films, the kind of sheen you'd see on heat-treated alloys. Others swore it looked like dust, but dust that behaved too neatly. You can almost picture it now, a tiny shimmer drifting through the void, not glowing like a comet, not dull like an asteroid, but gleaming as if the sunlight itself couldn't resist tracing every inch of its strange surface. In a universe full of ordinary grey rocks, 3I Atlas was posing like a disco ball. The first spectral readings were subtle, just little spikes on a graph. But the more the data came in, the weirder it got. The light bounced off 3I Atlas, as if it were coated in layers, maybe reflective, maybe transparent, maybe both. The pattern reminded some scientists of multi-layer films, the kind humans make in laboratories to reflect laser light. Others thought it resembled the diffraction of ultra-fine dust suspended in vacuum. And then, someone said the words that always make people sit up. It looks engineered. Now, to be fair, that doesn't mean aliens. In science, engineered can also mean coincidentally efficient. Nature is the original engineer, and she never reads the manuals. But still, there was something disquieting about how perfect that reflection was. Not too shiny, not too dim, just enough to bend models into confusion. Imagine you're standing in the desert at dawn, and the sun hits a distant car windshield. For a split second, the light blinds you not because the car is bright, but because it reflects exactly right. That's what astronomers were seeing, the kind of reflection that seems to wink, deliberately, before turning away. Theories began piling up like laundry on a dorm chair. Maybe 3I Atlas had a surface covered in complex frost layers of carbon dioxide and methane, crystallizing into thin, mirror-like planes. Maybe micrometeoroid impacts had melted and reformed its skin over time, leaving a glassy sheen. Or maybe, and this was the unsettling part, maybe it wasn't reflecting sunlight at all. Maybe it was scattering something else entirely. One researcher half joked that it looked like the world's smallest stealth satellite. Everyone laughed, but quietly. Because the reflection pattern wasn't random, it pulsed with an almost rhythmic consistency. Bright, dim, bright, dim. A kind of optical Morse code, written by distance and spin. When you imagine it, it's almost hypnotic. That slow, pulsing glow, turning over the emptiness, a heartbeat against infinity. It wasn't uniform either. Some parts of the surface flared warmer in infrared, others stayed cold as shadow. A normal object would have even heating. This one didn't. It was patchy, asymmetrical, too deliberate for comfort. If you could reach out and touch it, and of course, you can't, it might feel smooth in one place, pitted in another. Cold metal, hot seams. The kind of tactile contradiction that makes your fingertips tingle, just imagining it. Someone proposed that maybe it wasn't a single object at all, but a cluster fragments traveling together so tightly they appeared as one. The light curve disagreed. The glow moved as though the surface were continuous. Another theory. It was hollow, like a shell, thin enough that sunlight passed through in certain bands. That might explain the metallic shimmer light resonating inside, before spilling back out. But then came the strangest data point. A faint ultraviolet spike that didn't match any known mineral. It wasn't strong, but it was persistent, repeating night after night. The kind of spectral line that suggests chemistry behaving outside our expectations. Could be noise, one astronomer said, the same way someone says, could be nothing, right before it becomes everything. The media loved it. Headlines blared that it was a space probe from another civilization, because of course they did. But inside the scientific community, the tone was quieter, more like awe, wrapped in denial. Nobody wanted to say it out loud, but everyone felt it. The same prickling thought that haunted them since Oumuamua. What if the glow isn't a reflection, but an intention? You could imagine the scene in every observatory. The low hum of machines, the soft clatter of keyboards, the dim red light designed to protect dark-adjusted eyes. Outside, the wind across mountaintops. Inside, dozens of people holding their breath over a flicker of light, billions of kilometers away. 3i Atlas was not screaming for attention. It was whispering quietly, rhythmically, as if saying, "Notice me, but don't assume you understand." And that's the thing about glow. It's not the brightness that matters, but the reason something shines at all. Ice glows because it scatters light. Metal gleams because it reflects it. Fire burns because it makes its own. Which one was 3i Atlas? That was the riddle. As the days passed, the glow shifted, not fading, but changing hue, from pale gold to faint silver to a soft bluish tint that no one could explain. It was as if the object were wearing the sunlight differently, choosing its wardrobe depending on who was watching. Even after it slipped beyond the range of most telescopes, the last few images showed that eerie shimmer, not bright enough to dazzle, not dim enough to ignore, just steady, self-assured, like a candle that knows it's surrounded by darkness but refuses to flicker. And you, listening now, can almost feel that glow warming the inside of your thoughts. Maybe it's a trick of physics. Maybe it's a signature from something older, smoother, quieter than we can imagine. Or maybe it's just what wonder looks like when it travels at 50 kilometers per second. Whatever it was, the glow lingered a reminder that not all light comes to us for explanation. Some arrives just to say, "I'm here," and then keeps going. Let's float with it now just a little farther from the sun, where the light begins to lose its warmth and physics starts whispering. The first explanation was simple. Sunlight itself was pushing it. Radiation pressure could accelerate a thin, flat object. But to move like that, 3i Atlas would need to be impossibly light, thinner than paper, yet dozens of meters across. A cosmic sail, perhaps. You imagine it now. A glimmering sheet, wide as a football field, but delicate as ash, drifting on the faint exhale of sunlight. The entire thing shimmering with invisible tension, like silk catching the wind that isn't there. It sounds beautiful, and it is. But beauty, in science, is usually a warning that the math is about to misbehave. Radiation pressure is real. Every beam of light carries a tiny nudge, a packet of momentum. On Earth, it's too faint to feel. But in space, in the vacuum of silence, it can build, gently, endlessly. Over time, it can push dust, shape comet tails, even steer spacecraft with sails so thin they'd tear if you sneezed near them. The logic was simple. If light could move our technology, maybe it could move this visitor too. The trouble was, 3i Atlas wasn't built like anything natural. For sunlight to accelerate it the way the data suggested, it would need a surface area to mass ratio beyond comprehension, the same way a butterfly would need to weigh less than a whisper to stay airborne on hurricane winds. Astronomers tried to model it anyway. They gave it different densities, thicknesses, reflectivities. Every equation ended the same way. To move like that, it would have to be impossibly thin. Not fragile thin, absurdly thin. 1,000th the thickness of a human hair, floating alone between the planets. And that's when the human imagination started doing what it always does. When the numbers get weird, it started to dream. Maybe it's a light sail, someone said. The words hung in the air like static. Not an accusation, not a declaration, just a possibility. A sail, pushed by starlight, drifting between systems. A technology we ourselves had only just begun to play with. Or, someone countered, maybe it's a flake, a fragment of something larger, a sheet torn loose from an ancient world. Both explanations made sense. Both felt like poetry disguised as physics. Because really, what's the difference between a sail and a shard? One is made on purpose, the other by accident. Both catch light, both move on whispers. To test the idea, the team compared 3 iAtlas's acceleration with that of known light sails, the few human-made prototypes floating not far from Earth. The results were unsettlingly close. The object moved with a similar grace, responding to solar pressure, almost as if it expected it. It adjusted, ever so slightly, its rotation matching the rhythm of the sun's breath. Now, of course, the rational mind says coincidence. Nature is full of mimics, feathers that look like eyes, rocks that hum like instruments, comets that imitate craft. But deep down, you can feel it, can't you? That little pulse of wonder that refuses to sit quietly. The idea that perhaps, somewhere, light itself could be used as both fuel and language. Because imagine what that would mean. Not just motion, but communication. A sail could transmit information by reflecting sunlight in coded flashes, a Morse code written in brightness and shadow. And 3 iAtlas did flicker in patterns, remember. Rhythmic, deliberate, hauntingly regular, too regular to ignore. But here's where things twist again. If it truly were a sail, it should have aligned itself with the direction of the light to maximize thrust. It didn't. It tumbled, tilted, fluttered like a leaf that wanted to fall but never quite landed. That inconsistency ruined the neatness of the theory. A sail that refuses to face the sun is like a sunflower turning away from daylight. Possible, but emotionally suspicious. So, the scientists split again, half clung to the light sail idea, physics in motion, elegant and self-sufficient. The other half muttered about unknown materials, exotic dust, hollow carbon sheets, maybe something self-regulating. A cosmic origami that folds under heat, straightens under shadow, and thus moves by its own strange logic. There's comfort in that, in believing nature is simply outsmarting us again. But in quiet moments, and there were many of those, the first group whispered, what if it's not nature? Not as in alien civilizations with antennas and cities, but as in remnants, relics, leftovers from something older than our sun, drifting endlessly, still responding to the light that once gave it purpose. The idea is haunting and oddly peaceful, like finding a paper boat still floating in a pond decades after the rain. Maybe it means nothing, maybe it means everything, and so the debate continues. Radiation pressure, or something else. The truth hides somewhere between numbers and imagination, between formulas and poetry. 3 iAtlas keeps drifting, indifferent to both camps, obeying only its quiet physics. You, lying here now, can feel a small part of that mystery. The faint pressure of light against your eyelids, the warmth that traveled 90 million miles to reach you. If sunlight can move worlds, maybe wonder can too. Because sometimes the universe doesn't need rockets or engines to move you. Sometimes all it takes is a single beam of light and something thin enough to believe in it. Let's take a deep breath now, because this is where the silence begins. As it turned out, no one had enough data. The object's path was too quick, its window too short. Ground telescopes blinked, satellites turned, and then it was gone. All that remained were the numbers, the light curves, and a deep unease among the astronomers who'd seen them. You can almost feel that frustration. The universe, once again, dangled a mystery in front of us, then yanked it back into the dark, like a magician hiding his final trick. The telescopes had only caught a handful of nights, a dozen measurements, maybe 24 frames of brightness. Not enough to build a clear picture, just enough to keep everyone awake at 3 a.m., whispering, "What if?" Astronomy is full of ghosts like this, objects that appear, shimmer, and vanish before the math can catch them. But 3i Atlas wasn't just fast, it was fleeting. It moved through the inner solar system like a rumor that refused to repeat itself. Each observation felt like trying to take a photo of lightning using a potato. The problem wasn't the scientists, it was geometry. The thing came from a high, steep angle, past the sun at a blistering clip, and darted away into the dark. Even the world's largest telescopes struggled to keep up. By the time one observatory aimed its mirrors, another lost sight of it. Coordinating across the planet became a frantic relay race against light itself. Picture it, late-night calls between observatories across time zones, Hawaii to Chile to Spain to South Africa, voices crackling over static, everyone watching the same invisible point of sky. Do you have it? We had it. It's gone. The timestamps didn't align, the calibrations drifted, and every dataset arrived like a puzzle missing half its edges. It's easy to romanticize these moments, but for the scientists involved, it was agony. You can almost hear the sighs, long, quiet. The kind reserved for when you realize the universe has better things to do than hold still for your instruments. The data they did have were beautiful in their incompleteness. A flicker of light here, a dip there like notes in a melody that stops mid-song, enough to hint at meaning, but not enough to sing it. The object's brightness changed faster than expected, implying rapid rotation, but without continuous tracking, they couldn't tell whether it was a tumble, a wobble, or something stranger. At one point, a single telescope in Arizona caught what might have been a brief outburst, a faint flash that lasted less than 2 seconds. It could have been instrumental noise, or cosmic rays, or the last gasp of a comet shedding ice. But for weeks, the team argued about it, replaying the moment again and again, as though the truth might reveal itself if they stared long enough. When the window finally closed, the databases filled with silence. The coordinates were empty, the sky quiet. Even the software refused to extrapolate its algorithms, spat out warnings, trajectory uncertain, prediction unreliable. In cosmic terms, that meant we have no idea where it went. For a field built on precision, that kind of ambiguity is torture. Astronomers like neat lines and clean orbits, not disappearing acts. And yet, 3i Atlas reminded them of something uncomfortable, that most of reality happens when no one is looking. There's an odd humility in that. You spend decades building machines to study the heavens, and then the heavens casually move faster than your budget allows. It's like spending a lifetime learning to listen, only to realize the universe speaks in whispers shorter than your patience. Some tried to fill the gap with simulations. They fed the partial data into computer models, watching endless virtual versions of 3I Atlas spin and streak across imaginary skies. Each model was different, each plausible, none definitive. The missing data became a kind of canvas, wide, open, dangerous, where every theory could live without dying. And maybe that's why the mystery grew so large. The fewer the facts, the larger the imagination must stretch to fill the void. In that gap, 3I Atlas became everything: a comet, a shard, a sail, a relic, a whisper of alien craftsmanship, a cosmic accident. The lack of information didn't kill the story, it gave it wings. Some scientists hated that, others quietly loved it, because in science, a mystery is oxygen. It keeps the field alive, keeps grants flowing, keeps late-night coffee brewing. A solved problem is comforting, an unsolved one is addictive. You might think of 3I Atlas as the universe's version of a half-written note slipped under the door. I was here, it seems to say, but you weren't quick enough. The message isn't cruel, it's just honest. In a cosmos measured in billions of years, a few weeks of observation barely counts as a blink, and maybe that's the lesson. That knowledge isn't lost in silence, it's forged in it. The data gap isn't a failure, it's an invitation. It's the cosmos saying, "Catch me if you can," while already vanishing beyond the reach of our instruments. So tonight, as you settle into stillness, imagine that flicker fading out of sight, the final line of light disappearing beyond Neptune's edge. You can't chase it anymore. You can only wonder what stories it carried. And maybe that's enough, because sometimes what we don't see is what keeps us looking up. Let's step now into the quiet hum of the data room, where numbers, not telescopes, tell the story. You can tell something's wrong when mathematicians start using words like peculiar. The orbital solution of 3I Atlas produced residuals, tiny mismatches between prediction and reality that refused to vanish, no matter how refined the model became. Now, to most of us, a residual sounds harmless, like an afterthought, or maybe a dish you forgot to wash. But in orbital mechanics, a residual is the ghost in the equation, a small, stubborn difference between what should be happening and what actually is. And 3I Atlas was full of ghosts. It began with a curve, a simple plot of where the object should go next. Every new data point nudged the curve, as expected, but not by much. The real problem came when the math tried to predict forward. No matter how many parameters they added gravitational corrections, solar pressure, planetary influences, the model drifted. The orbit refused to stay obedient. It wobbled like a drunk compass, trying to find north. You could feel the unease spreading in the control rooms. Astronomers deal with error margins all the time. They live in decimals and uncertainty. But this was different. The pattern wasn't noise, it was structure. Each residual had direction, like the object was responding to something invisible. And that's the part that makes mathematicians nervous, when the randomness starts looking a little too organized. So they started recalculating. Different teams, different methods. The results were eerily consistent. Everyone got the same weirdness. Some models showed a slow outward drift, as if a faint, constant force were pushing on the object. Others showed a periodic oscillation, like a heartbeat embedded in the numbers. "It's breathing," one grad student joked, and everyone laughed the kind of laugh people do when they don't want to be the first to stop. The thing about orbital math is that it doesn't like personality. It's supposed to be clean forces, vectors, trajectories, nothing emotional. But 3I Atlas's path had mood swings. It bent slightly when it shouldn't have, lingered near the sun a little too long, left with more speed than it arrived. It was as if the equations themselves were whispering, "I can't explain this, but isn't it fascinating?" One senior analyst in Prague tried brute forcing the problem, plugging in every known variable, from radiation pressure to planetary tides. The result still left a gap, a discrepancy just large enough to be real, and just small enough to ruin everyone's sleep. When your entire career is built on precision, a single, uncooperative decimal feels personal. So they gave it a nickname, the Wiggle, because somehow, naming it made it less terrifying. The Wiggle became shorthand for the thing nobody could fix. Reports circulated quietly. Object exhibits non-linear deviation at perigee, marginal but consistent acceleration bias. Translation: the numbers are being weird again. This is the moment when science becomes something poetic, not because of imagination, but because of limits. When you reach the edge of explanation, the math starts to sound like metaphor. The equations for 3I Atlas began reading like riddles. What moves but is not pushed? What turns but is not bound? And you, if you were sitting in that lab, might feel it too. That shift from logic to awe, the way the glow of computer monitors paints every face in the same pale light, the way the silence stretches as another simulation finishes with the same result, incomplete. Someone suggested maybe the data was corrupted, always a comforting thought, but cross-checks with other observatories proved it wasn't. The Wiggle wasn't a glitch, it was real. At this point, the community split again, the pragmatists versus the poets. The pragmatists blamed unseen gas jets, asymmetric heating, microthrusts from outgassing too faint to detect. The poets looked at the curve and saw intention. They didn't say the A word no one dared, but you could feel it pulsing beneath the conversations like a second heartbeat. The arguments spilled into preprint servers and late-night email threads. Graphs attached, equations scrawled in desperation. The polite tone of academia slowly eroded into phrases like highly improbable and statistically inconsistent. For scientists, that's basically yelling. In a rare moment of honesty, one researcher wrote, "If this residual pattern were found in a spacecraft's trajectory, we'd assume an active control system." The sentence hung there in the data like a confession. Of course, that didn't mean it was controlled, only that the math didn't know how to describe anything else. There's something oddly human about that. Our instinct to assign intention, where we find structure, to look at a set of numbers and imagine personality. But maybe that's the point. The math wasn't nervous because it failed. It was nervous because, for a moment, it felt alive. In the end, they archived the data under the label non-gravitational anomaly, source indeterminate, a phrase so polite it could be engraved on a tombstone. The residuals still sit there in digital silence, curves, deviations, hints of motion that don't belong. And maybe, in a way, that's the perfect outcome, because every now and then, the universe needs to remind even its most devoted calculators that certainty is a luxury, that no amount of digits can measure curiosity. So next time you see a graph that refuses to behave, remember 3I Atlas, the visitor that made math nervous. Because when equations twitch and decimals rebel, it usually means something extraordinary just passed through. Let's lean closer now, right up against the static, where information becomes uncertainty and uncertainty starts humming. Some argued the anomaly was an illusion, the result of observational bias, faulty calibration, or the simple chaos of measuring a fast, fading object. But when multiple independent teams reported the same residuals, noise stopped sounding convincing. At first, the explanation seemed elegant. It's just data noise. The oldest excuse in astronomy. Cosmic rays can strike a sensor, causing phantom points of light. Telescopes can vibrate, mirrors can flex, software can misbehave after midnight. All the little gremlins that live inside precision. It happens all the time. But this noise was polite, too polite. It showed up in the same place, at the same intervals, across multiple observatories, even those thousands of kilometers apart. Different instruments, different nights, same twitch in the graphs. That's not noise, that's choreography. Imagine being one of the analysts, staring at those faint, spidery lines, data curves that should have been smooth, but weren't. Each graph like a heartbeat monitored by a nervous doctor. You'd check your calibration logs, your timestamps, your software builds. You'd cross-reference with satellite data, with weather patterns, even with passing air traffic. You'd do everything right. And the wiggle would still be there, grinning at you from the data like static that learned to spell. It's a peculiar thing about science. When the results are too clean, we suspect fraud. When they're too strange, we suspect error. Either way, the human brain demands a culprit. So the first week, they blamed the instruments. The second, they blamed the analysts. The third, they blamed the sky. But then something unsettling happened. The pattern began repeating even after 3i Atlas had vanished beyond optical range. Observatories continued collecting background data for calibration purposes, and faint echoes of the same anomaly appeared again. Same signature, same rhythm, only now in deep field starlight. It was as if the noise had learned to linger. Of course, that shouldn't be possible. Once the object was gone, any related data should have disappeared too, and yet the signal remained, hovering just above the threshold of randomness, like an afterimage. When you stare at a bright light too long, one researcher described it beautifully. It's like hearing a melody once and then realizing the silence afterward still hums in the same key. They ran the tests again, this time blind. No one told the observers what they were looking for. Still, they found it. The same slight deviation in brightness, the same shimmer in the noise. That's when the term correlated error began making the rounds, a phrase so bland it could hide anything. But among themselves, the astronomers started calling it the echo, because, really, what else do you call a sound that persists after its source has vanished? You can picture the scene, the control rooms bathed in low red light, computers humming, coffee cooling untouched beside keyboards, data streams rolling in from telescopes around the world. And somewhere in that flood of numbers, the faint, rhythmic pulse that shouldn't exist. Someone joked that maybe 3i Atlas had left behind a gravitational footprint. Others said maybe the sensors were haunted by solar interference. One even half-seriously proposed that the object emitted polarized light that interacted with the instruments themselves, not by energy, but by memory, as though it had brushed against their detectors and left fingerprints. The press never heard about that theory. Some mysteries are too delicate for headlines, but among the quiet corridors of astronomy departments, the echo became legend. Not proof of anything, just a reminder that the universe occasionally coughs in the middle of your measurements. The skeptics, of course, doubled down. They insisted the anomaly was a product of bad data processing. Too many hands, too many filters, too many assumptions layered on top of each other. We're seeing patterns in static, they said. It's pareidolia for scientists, the cosmic equivalent of seeing faces in clouds. And yet, clouds don't line up across continents. So the teams published their findings cautiously, one paragraph at a time, draped in disclaimers. The observed residuals are unlikely to arise from random error. Further investigation is warranted. Academic language for, we have no idea what's happening, but it's probably important. And the funny thing? No one could replicate it. Months later, when they pointed their telescopes back to the same coordinates, the noise was gone. Clean sky, smooth graphs. Whatever 3i Atlas had done to the data or to their imaginations, it had vanished completely, like a whisper carried off by cosmic wind. You, listening now, might feel a strange comfort in that, because sometimes the unknown is kind enough to erase itself before you start losing sleep. Sometimes the universe leaves just enough breadcrumbs to make you curious, but not enough to drive you mad. Still, in late-night conferences and quiet emails, that word lingered echo, a word that implies not just sound, but response. Something heard, something returned. Maybe it really was noise. Maybe the instruments were whispering back to themselves. Or maybe, for a brief moment, they brushed against something real, something too faint to name, but too structured to ignore. Because in the end, noise is only noise until it starts keeping time. Let's open the door a little wider, step back, and see this not as one odd event, but part of a growing pattern. Before 3i Atlas, only 2 interstellar objects had ever been confirmed: Oumuamua in 2017 and 2i Borisov in 2019. Borisov was an icy comet. Understandable. Oumuamua was strange. 3i Atlas. Stranger still. 3 data points, and already a trend. Astronomers love trends. They make the cosmos feel slightly less chaotic, like the universe has the courtesy to rhyme. And so, with the arrival of 3i Atlas, something quietly thrilling began to take shape, a realization that our solar system might not be as private as we thought. For billions of years, chunks of rock, ice, and cosmic dust have been crossing the vastness between stars. We simply hadn't noticed. Our telescopes weren't sensitive enough. Our sky surveys too narrow. The first confirmed visitor, Oumuamua, appeared almost by accident, a cosmic tourist we spotted only after it had already passed us. When it was discovered, scientists felt like archaeologists finding footprints, but not the traveler. It had come from nowhere we could trace, and was gone before anyone could blink. Its light curve flickered strangely, its shape defied assumptions, and its acceleration refused to behave. It was the kind of mystery that turned cautious professionals into poets overnight. 2 years later came Borisov, the second interstellar object, 2i Borisov, discovered by an amateur astronomer with a homemade telescope. It looked more familiar, a bright nucleus, a tail of gas and dust, behaving exactly like a textbook comet. Astronomers sighed in relief. Finally, something sensible. A normal alien visitor. But then came 3i Atlas, and all that comfort dissolved like ice in sunlight. If Oumuamua was a messenger and Borisov a reassurance, 3i Atlas was a question mark, sharp, bright, and unsettling. It didn't fit the pattern. It didn't even fit the exceptions. It was fast but graceful, solid but weightless, bright but silent. The universe had knocked twice politely, then kicked the door open on the third try. To understand how extraordinary that is, you have to remember, interstellar objects shouldn't be easy to find. Space is vast. The distance between stars is absurd. Even if trillions of fragments wander between systems, the odds of one crossing our small solar neighborhood and us noticing are minuscule. Yet here we are, with 3 in less than a decade. It's as if the galaxy had been tossing stones through our window for eons, and only now we've finally started to hear the glass ping. The realization brought both excitement and unease. Were these random drifters, or did something make our system particularly attractive lately? Maybe it's just coincidence, or maybe, as one researcher half joked, The neighborhoods got noisy. Each of the three visitors carried its own personality. Borisov, the traditionalist, trailing gases, behaving like a comet should. Oumuamua, the enigmatic one, all straight lines and silence, gliding like it had somewhere to be. And 3i, Atlas the rebel, shimmering, accelerating, changing color like a mood ring lost in space. 3 data points are enough to suggest a pattern, but not enough to define it. That's what makes scientists twitch. It's the cosmic equivalent of a trilogy that ends on a cliffhanger. You can feel something coming, but you don't yet know what. Some theorists propose that maybe we're simply seeing what's always been there, the observational equivalent of finally buying glasses. Our new sky surveys, especially Atlas and Pan-STARRS, scan the heavens continuously, catching what older systems missed. "We're not special," one astronomer said. "We're just paying attention for once." Still, others weren't so sure, because randomness has a rhythm too, and this one felt too deliberate. Each new object stranger than the last, each arrival rewriting the rules we thought we'd mastered. Some half-seriously called it the interstellar escalation. You can imagine the tension in conference rooms, scientists trying to sound calm while their PowerPoints quietly implied panic. Slide after slide showing comparisons, Oumuamua's light curve versus 3i Atlas's spectral shifts, Borisov's tail versus 3i Atlas's eerie metallic sheen. The graphs didn't match, but their weirdness did. By this point, the public had started to notice too. Space fans, bloggers, amateur astronomers, everyone began watching the skies with renewed fascination, as if another visitor might show up any day. And that's the strange beauty of it. A single mysterious object can transform millions of people into dreamers again. For the professionals, though, the stakes were heavier. 3 interstellar visitors in 8 years isn't just interesting, it's unsettling. It suggests a new population of objects moving between stars, maybe more common than we ever thought. Some might be cometary debris, others could be fragments from shattered planets, or relics of ancient systems long gone. But there's also a quieter possibility, one that whispers beneath all the official papers. What if some of these things were built? Not alive, not piloted, just built, long ago, by something that knew how to sail on starlight. If civilizations rise and fall across eons, wouldn't some of their artifacts survive adrift, abandoned, but still obedient to the physics of light and motion? It's a thought that hovers in the background, unspoken but electric, because whether you believe in extraterrestrial intelligence or not, the idea that we might already be tripping over its leftovers feels strangely inevitable. So when 3i Atlas streaked across the detectors, blazing and whispering, and accelerating in defiance of gravity, the astronomers didn't just see a rock, they saw continuity, a story told in 3 acts, with a missing 4th one still on the way. Maybe in 10 years, or 20, another will arrive 4i, something spinning and glinting, carrying yet another question wrapped in silence. Maybe it will make sense, maybe it won't. But for now, all we can do is look back at these first 3 visitors, a trilogy written across the stars, and wonder if the galaxy just started talking, or if we only just learned how to listen. Let's follow its path backward now, or at least try to, because the story of 3i Atlas doesn't just lie in where it went, but where it came from. If 3i Atlas came from another star, which one? Simulations traced its path backward across the Milky Way, but the trail dissipated into uncertainty. Too many stars, too much motion, too many years. It was as though it emerged from statistical fog, the universe's version of a jump cut, tracing the origin of an interstellar object, is like trying to find the hometown of a snowflake. Every star moves, every system drifts. The galaxy is a carousel spinning at hundreds of kilometers per second, its arms sweeping through space like slow-motion waves. Even if you could rewind time, the stars themselves wouldn't be where you left them. The astronomers tried anyway. They fed 3I Atlas's orbital data into simulations thousands, then millions of runs, each one rewinding the galaxy's clock. A few thousand years, then a few million, then a few billion. What they got wasn't a straight line, but a smear, a fading fingerprint of probability. At first, one region stood out, the constellation Cassiopeia, that familiar W etched into the northern sky. For a few weeks, the models suggested that might be where it came from. But then the uncertainty ballooned. A tiny shift in the object's speed, even a fraction of a meter per second, changed everything. Its supposed origin jumped from Cassiopeia to Cygnus, then to an empty stretch between stars. Each new refinement made the map less certain, not more. It's a humbling thing to chase something backward through time and realize that time doesn't like being chased. The further they looked, the fuzzier it became, until eventually all that was left was possibility, a cloud of maybes drifting across the galactic plane. One researcher described it like this: "It's as if it didn't come from anywhere, just appeared from the statistical noise of the Milky Way itself." You can imagine them staring at the holographic models in their labs, spinning stars, shifting paths, the faint thread of 3I Atlas, dissolving into a mist of dots. The galaxy looked less like a map and more like an impressionist painting, all motion, no edges. To make matters worse, the galaxy is full of gravitational troublemakers, giant molecular clouds, rogue planets, passing stars. Each can nudge a wandering object just enough to rewrite its past. Even if we had the perfect trajectory, we couldn't unwind all those invisible pushes and pulls. The universe has too many fingerprints. So instead, the teams began to speak not of where it came from, but what kind of place could produce something like it. If it wasn't a comet or an asteroid, what sort of system would birth such an object? A shattered planet? A star system with unusually strong radiation pressure? A debris field from a dying sun? Some thought of binary systems, twin stars whose gravitational dance can fling debris outward at escape velocity. Others imagined cataclysmic explosions, supernova remnants spitting shards of once solid worlds into the galactic void. A few more daring minds whispered about civilizations, the ancient hypothetical kind that might have once launched sails across the stars long before our planet cooled. Each theory said more about the humans proposing it than the object itself. The real data was silent, indifferent, but silence, in science, is never empty. It's an invitation for imagination. There's an old saying among astronomers: all orbits lead home eventually, meaning that if you trace any trajectory long enough, it connects to something, a source, a cause, a beginning. 3I Atlas was the exception. It was the first object they couldn't tie to any star, any region, any motion. It was as if the galaxy had reached into its own pocket and tossed us a coin from nowhere. You, listening now, can picture that coin spinning endlessly between stars, light flashing across its surface, until one day, by random grace, it lands here. It doesn't announce itself. It doesn't linger. It just passes through, carrying stories it refuses to tell. And maybe that's the point. Maybe not everything in the universe has an origin we can name. Maybe some things are just wanderers, not from somewhere, but from between systems, between epochs, between certainties. In a way, 3I Atlas is a symbol of everything we don't know about motion itself. Because while we imagine the galaxy as a fixed collection of stars, it's more like an ocean in slow swirl, everything moving, everything drifting, everything temporary. And in that endless current, now and then, something crosses our path, a glint of debris, a forgotten echo, a question pretending to be an object. One of the last reports about its origin ended with a single line, quiet and almost poetic. No definitive source identified. Object may originate from dynamically unassociated interstellar medium. Translation: it came from nowhere, and we'll never know where nowhere is. So perhaps the question of origin isn't one we're meant to solve, but one we're meant to feel, that tingling awareness that every now and then the universe delivers something untraceable, something that refuses to be claimed. And maybe that's comforting, because in a galaxy full of predictable stars and obedient planets, it's nice to know that mystery still travels freely. No passport, no address. Just a quiet arrival, a brief shimmer, and then gone back into the fog from which all beginnings are made. Let's imagine for a moment that 3i Atlas wasn't built or sent, but simply found its way here, a wanderer, not a messenger. Some scientists likened it to cosmic debris fragments thrown from young star systems, wandering for eons through interstellar tides until gravity caught them. If so, each interstellar object is a message in a bottle, its composition a note from another world's geology. It's a beautiful thought that every time one of these visitors streaks past our sun, we're glimpsing the history of a world that may no longer exist, just driftwood, carried on galactic tides, arriving on our cosmic shore. Picture it. Somewhere, long ago, a planet orbits too close to its young star. The system is chaotic. Collisions, radiation storms, gravitational tantrums. A moon fractures. A crust cracks. A shard, light and silent, slips free of its parent world. It floats for millennia, leaving behind the light of its birth, crossing voids so vast that even the speed of thought would grow tired halfway there. And one day, by nothing more than chance, it brushes past our star. That shard, that piece of forgotten planet, might be what we call 3i Atlas. To the scientists who prefer modest explanations, that's the poetry that feels safe. The galaxy is messy. Stars fling debris like toddlers throwing toys. Every collision creates fragments. Every fragment takes a billion-year journey. Some end up orbiting new suns, some become comets, and a very lucky few drift into the warm, curious gaze of a species that still names things it barely understands. The math supports it too. Models of planetary formation predict that trillions of objects are ejected into interstellar space every year. Most are dust, some are rocks. A few, perhaps the lucky, lonely few, are large enough to survive interstellar erosion and shine bright enough to be noticed. Astronomers call them interstellar interlopers, a polite phrase that hides the grandeur of what they truly are. Fossils of alien systems, still wandering long after their stars have changed. You, listening now, can imagine them like driftwood on an infinite ocean. Each piece carries the memory of the world it came from, the chemical whispers of its soil, the metallic sighs of its mountains. Some may contain frozen gases that once painted the skies of other planets. Others may be fragments of cores, heavy with iron and nickel, the bones of alien worlds shattered by time. And here's where it gets even more poetic, or unsettling, depending on your temperament. Some of those worlds might have had oceans, atmospheres, maybe even life. If their planets were torn apart by cosmic chaos, then pieces of those living worlds might still be floating through space, little geological time capsules, carrying within them the dust of vanished civilizations, the ashes of alien forests, the chemical ghosts of forgotten biospheres. We might be walking under skies crossed by the remains of long-dead ecosystems, their atoms drifting past our sun like a slow, quiet eulogy. It's not so far-fetched. On Earth, meteorites from Mars have landed in Antarctica. We've already proven that worlds can exchange debris across millions of kilometers. Scale that up to the galaxy, and the idea of interstellar driftwood becomes less poetic and more inevitable. Some scientists even wonder if such fragments could carry life itself, microscopic spores or dormant molecules, frozen and shielded for eons until they find a new home. The idea is called panspermia, the cosmic seed theory. Life, not born once, but scattered, shared, recycled, every star a potential gardener, every fragment a tiny ship carrying biology between worlds. Imagine that. 3I Atlas, not just a rock, but a seed that never sprouted. Of course, that's speculation, the kind that drives both excitement and migraines in equal measure. No one's claiming proof. Still, the possibility changes how we see the sky. Suddenly, the black between stars isn't empty. It's full of driftwood, full of memory. You might be tempted to see 3I Atlas as a kind of mirror, a way to glimpse what other solar systems look like without ever leaving home. Spectral analysis, after all, is a kind of reading. Every wavelength of reflected light tells a story: what minerals it's made of, how it was formed, what temperatures it has endured. Each interstellar visitor carries a page from another planet's history book, written in the language of photons. And yet, 3I Atlas's pages were half erased, its story incomplete. Its spectra didn't match any known rock, ice, or metal. It was like driftwood made from something that no longer exists, a kind of matter that didn't belong to any familiar world. That's what makes it haunting, because if it is driftwood, then it came from a sea whose currents we don't yet understand. You, sitting quietly in the dark, can almost imagine the sound of that sea, slow, patient, infinite. The galaxy's waves rolling between stars, carrying fragments from world to world. Each one silent, each one ancient, each one asking the same question without words. Where did I begin? Maybe 3I Atlas was just another piece of cosmic debris, another splinter of a forgotten planet passing by. Or maybe it was something rarer driftwood carved not by nature, but by time itself, smoothed by millions of years until it became indistinguishable from perfection. Either way, its journey reminds us that we live in a galaxy full of travelers, and that, in some quiet way, we're driftwood too, spun out from the stars that came before us, floating through space and centuries, still glowing faintly with the heat of our origins. Let's drift forward again, not through space this time, but through revelation, that strange territory where discovery tiptoes into disbelief. But new spectral data, quietly released in May 2025, hinted at something wilder. There were spikes in reflectance where none should be, metallic traces perhaps, or layered silicates arranged too neatly to be random. The team called it structural coherence. Now, structural coherence is one of those scientific phrases that sounds calm, like a librarian describing an earthquake. What it meant, in simple terms, was that 3I Atlas didn't just reflect light, it organized it. The wavelengths bounced back in patterns too precise for chaos, too regular for chance. You can imagine the moment the data first appeared on screen. A thin curve, rising and falling like the pulse of something that didn't know it was being watched. To the untrained eye, it was just numbers. To the scientists who had spent months analyzing blank noise, it looked like a message written in the language of physics. At first, they thought it was a calibration error, the kind of hiccup that happens when your telescope's mirror is slightly too warm, or your detector picks up stray light from the moon. But after cross-checking across multiple observatories, the pattern remained. Not noise, not error, something real. The spikes were evenly spaced, like teeth on a comb. They appeared in the near-infrared spectrum wavelengths that typically reveal mineral composition, surface roughness, or thermal effects. But this was none of those. The peaks were too clean. No natural rock should behave like that, not even under the strangest interstellar conditions. When one researcher plotted the data and tilted the graph sideways, the pattern looked almost geometric. It wasn't random scatter, it was rhythm, like bricks laid in a perfect line, or light bouncing off parallel surfaces. That's when someone muttered the phrase that would quietly haunt every conference afterward. It looks engineered. Of course, no one wrote that in the official report. The formal phrasing became evidence of structured reflectivity, which is scientists speak for, we don't know what this is, but it's unnerving. To understand the magnitude of that phrase, you have to remember what random looks like in space. Natural objects, asteroids, comets, moons are messy. Their surfaces scatter light in all directions. They're rough, chaotic, scarred by impacts and baked by radiation. Even when they glint, their glint is sloppy, their reflections uneven. 3. Atlas didn't behave that way. It shimmered. It had symmetry, not perfect, but suspiciously close. Its spectral fingerprint suggested thin layers of material stacked like sheets, each interacting with light in slightly different ways. That could happen naturally, but rarely, very rarely. The phrase layered silicates began circulating minerals that can form in sedimentary or metamorphic processes. On Earth, they appear in clays, schists, even ceramics. The data hinted that 3I Atlas might have similar layering, alternating bands of material aligned just so. The problem? In space, random impacts and radiation tend to erase patterns. Over millions of years, everything gets sandblasted to chaos. For something to retain fine layering across eons of interstellar travel, it must have been formed or protected in a way we don't yet understand. So theories multiplied like galaxies. Some proposed that the layering was the result of shock waves. From its violent ejection, a planetary crust ripped apart and frozen mid-explosion. Others suggested a kind of mineral self-organization, where thermal cycling created order out of disorder. A few brave ones whispered about structures vast, long-dead megastructures shattered long ago, their fragments still drifting, pretending to be stones. You can almost feel the tension in those rooms, the low murmur of scientists pretending to be calm, while their monitors quietly accuse them of discovering something impossible. The world outside kept turning, oblivious, while inside the labs the word artifact hovered like static no one dared to touch. Someone inevitably ran the numbers. If the coherence pattern was genuine and not a trick of observation, then 3I Atlas's surface reflectivity matched no known mineral or composite. It was too stable, too resilient, too symmetrical. It reflected sunlight like a material built for efficiency, like something that wanted to move when pushed by light. Sound familiar? It should. The idea of a light sail revisited, rebranded, reborn in the data. Only this time, the evidence wasn't acceleration. It was structure. The official paper tried to keep a straight face. Observed coherence may result from fine stratification of silicate compounds, possibly indicative of unique interstellar weathering processes. Translation: we have no idea what's going on, but please stop emailing us about aliens. Still, the whispers spread. Independent labs tried to replicate the analysis. Some succeeded, some didn't. A few found even stranger sub-patterns, harmonic intervals in the data that looked almost mathematical. One physicist joked, "It's like the object is humming." Another replied, "Then the tune's been playing for 1 billion years." You, sitting there in the quiet dark, might wonder how something could travel for eons through chaos and still hold a pattern that neat. Maybe it's not proof of life. Maybe it's proof of persistence, that even matter, under pressure and time, finds ways to remember its origins. Or maybe it's driftwood again, not just floating, but carved, smoothed by motion, until structure becomes art, until randomness folds into order. Whatever it was, the anomaly deepened, not into panic, not into headlines, but into silence, that fragile kind of silence that happens when curiosity and fear hold hands, because the universe had just revealed a shape where there shouldn't have been one. And from that moment on, every telescope in the world began to wonder, not just what 3i Atlas was, but who might have made the light behave that way. Let's spin things gently now, not too fast, just enough to feel the rhythm, because in the motion of 3i Atlas, there was something that made even the most grounded physicists quietly nervous. In physics, natural things are messy. Rocks tumble irregularly, comets fragment, but 3i Atlas's spin appeared regular, too regular, almost as if engineered for balance. One researcher half joked, "If it's a rock, it's a very disciplined one." And that's the thing, discipline isn't something the cosmos usually bothers with. Chaos is nature's default. Asteroids wobble, tumble, precess, like drunks on ice. Their rotations decay as they lose energy. Their moments of inertia shift with every micrometeorite impact. But 3i Atlas, it pirouetted, gracefully, predictably, patiently. At first, astronomers thought it was coincidence, a fluke of geometry. The object's light curve showed repeating fluctuations every few hours, suggesting a rotation period that didn't change from night to night. Most comets show irregularities, jagged peaks, uneven dips, but this one was smooth, too smooth. If you charted the brightness over time, it looked like a sine wave, clean, periodic, hypnotic, not the chaotic blip pattern of a rock, but the steady pulse of a metronome. Now, in science, perfection is rarely a comfort. A perfect curve often means something's wrong either with your instruments or your assumptions. But after recalibration, reanalysis, and cross-verification across multiple observatories, the data stood its ground. The spin was consistent, the amplitude steady. The first team to publish the findings included an almost apologetic footnote. The rotation curve displays an unexpectedly low variance, suggestive of unusual homogeneity in surface reflectivity or structure. Translation: it's spinning too well, and we don't know why. Of course, the jokes began immediately. One astronomer quipped that maybe it had excellent posture. Another said it must have attended finishing school for comets. Laughter, in these circles, is how you keep the existential dread from making eye contact. But beneath the jokes, the implication was unsettling, because a stable rotation like that implies something about mass distribution, that the object's interior is evenly balanced. Natural fragments, especially those formed by collisions or erosion, are lumpy and uneven. To maintain such balance, 3i Atlas would need to have symmetry, not perfect, but intentional. That word intentional is the kind of word that derails entire conferences. No one dared write it in papers. but it haunted the after-hours discussions, the side conversations at hotel bars during astronomy summits. What if this wasn't luck? What if the balance was built in? You, listening now, might imagine the object turning slowly in the darkness, catching sunlight like a slow heartbeat. The light waxes and wanes, smooth as breathing. No jerks, no jitters, no cracks, just rhythm. You'd swear it was alive, if rocks could dream. Some researchers proposed a simpler explanation. Maybe 3I Atlas wasn't solid at all. Maybe it was a loose aggregate, a rubble pile held together by weak gravity, its parts naturally redistributing to a balanced form. But that theory didn't match the light data either. Rubble piles wobble, they shed dust, they crumble. This one didn't. So others tried the opposite extreme. Maybe it was metallic, a solid mass of iron or nickel, dense enough to spin cleanly without distortion. But if that were true, its albedo, the measure of how much light it reflects, should have been low. Instead, it gleamed. Metallic enough to shine, light enough to accelerate, symmetrical enough to balance. A trifecta that made no sense. One young researcher, in a moment of frustrated honesty, wrote in their notes, "It's like someone built it to spin." That note never made it into the publication, of course. It just lived quietly in the margins of a notebook, next to doodles of ellipses and orbit lines. The spin problem fascinated everyone because it touched something primal in physics. The idea that motion, once started, reveals truth. Every planet's day length, every moon's wobble, every asteroid's tumble tells the story of how it formed. To move perfectly is to erase history. To rotate flawlessly is to hide your scars. And 3I Atlas moved as if it had no past. Even stranger, its rotational axis, the imaginary line it spun around, appeared stable. No precession, no drift. That's extremely rare. Space is full of nudges, solar wind, micrometeoroids, subtle gravitational tides. Over time, these forces twist everything off kilter, yet this thing held steady, like a compass that refused to point anywhere but true. One paper delicately phrased it. Persistent angular stability suggests either unusually high rigidity or compensating surface geometry. Translation again. Either it's made of something we don't know about, or it's correcting itself. The idea of self-correction rippled through the community like an electrical pulse. Nobody believed it, not really, but nobody could dismiss it either. If the shape was aerodynamic in vacuum terms, it could naturally stabilize under sunlight pressure, much like a sail aligning itself with the wind. But that would require precision edges, contours, intentional geometry, the kind that nature, for all her artistry, doesn't usually bother with. Still, the official explanations stayed humble. Unusual material, uncommon symmetry, or a 1 in a trillion accident. But late at night, when the observatories dimmed and the sky hummed with quiet data streams, you could feel the other theory breathing softly in the dark. Maybe 3I Atlas wasn't a rock that learned to spin. Maybe it was something that remembered how. Because sometimes, perfection isn't an accident. It's a story that's been rehearsed for a very, very long time. Let's pause for a moment and look up really. Look up at the endless sprawl of stars above your mind's horizon. Because what 3I Atlas did wasn't just pass through our solar system. It rewrote, in the softest way possible, the way we think about being here at all. Finding a third interstellar object should have been routine, a quiet addition to the catalogue. Instead, 3I Atlas reignited debates about cosmic engineering, natural versus artificial origins, and how little we understand about debris between the stars. In theory, this should have been a footnote, a curiosity appended to Oumuamua and Borisov, an incremental data point that fit comfortably into existing models. Instead, it became a question mark large enough to cast a shadow across disciplines. Because when something defies tidy categories, scientists have two options: build new boxes, or admit the universe doesn't care about boxes. What made 3I Atlas different wasn't only its behavior, the spin, the glow, the two perfect curves, but the timing. By 2025, humanity's eyes were sharper than ever. New sky surveys were watching everything that moved. Satellites fed live telemetry into AI filters, and for the first time in history, the night sky was being quantified almost in real time. If something odd happened, someone noticed, which meant that the oddness of 3I Atlas wasn't just observed, it was witnessed, and with witnessing comes wonder, and with wonder comes argument. The debates unfolded like miniature galaxies of speculation, spiraling outward in all directions. One camp insisted on natural causes. Physics, always physics. They pointed to complex mineral layering, radiative acceleration, thermal stress, all the usual suspects in the detective lineup of celestial mechanics. Unusual doesn't mean unnatural, they said, which is true. Nature, after all, is the greatest sculptor of the improbable. But the other camp whispered differently. They pointed to the too precise rotation, the light coherence, the acceleration, the faint harmonic echoes in the data. They didn't say artificial, they said non-random, which, in science, is the same thing whispered behind a closed door. It's a funny thing about our species, how allergic we are to randomness when it doesn't behave properly. We crave pattern, story, cause. When the cosmos offers ambiguity, we turn it into myth. Maybe that's not weakness. Maybe it's survival. The universe is vast and silent, and humans have always filled silence with meaning. Still, there was something about 3I Atlas that refused to stay politely silent. Its behavior kept nudging against our understanding, not enough to prove anything, but just enough to keep curiosity awake at night. It was the cosmic equivalent of a cat knocking a single glass off the table every few hours, reminding us who's really in charge. To the engineers, it was a challenge. If it is natural, one said, we need to know how to build something that's stable. To the philosophers, it was poetry. If it's not natural, another mused, then we've already been found. The truth probably lives somewhere in the middle, which, ironically, is the most mysterious place of all. Because whether 3I Atlas was a rock, a relic, or a sail, it exposed a simple fact. We don't know what's floating out there. The space between stars once imagined as empty is more like an ocean strewn with fragments, relics, seeds, signals, junk, miracles, and maybe we're just starting to notice the driftwood washing up on our shore. That's why it matters. Not because it might be alien, but because it forces us to reconsider what interstellar space really is. Not a void, but a conveyor belt of stories. Every object that wanders in carries a piece of another system's autobiography. Minerals from a planet's crust, gases from a newborn star, structures from forces we don't yet have names for. Before Oumuamua, the idea of interstellar debris was theory. After Borisov, it was confirmation. After 3I Atlas, it became confession. The universe isn't just alive with stars, it's littered with their leftovers. And there's humility in that. Because for centuries, humanity looked outward and assumed we were spectators. But the moment we spotted something that came from outside, we realized we're also part of the scenery. Our solar system isn't isolated. It's just one pebble in a galactic tide pool. Somewhere, Light years away, another civilization, if it exists, might be watching our debris drift past their sun right now. Maybe they're analyzing its spectra, arguing about structural coherence, wondering whether the faint glint they're seeing is natural or intentional. The irony is delicious. Two species on opposite sides of eternity, both squinting at space dust, both trying to recognize themselves in the reflection. You can almost smile at that thought, because even if we never find proof of company, we've already found kinship in physics, in motion, in curiosity. Every wandering fragment, every interstellar intruder is a cosmic handshake across impossible distances. So yes, 3I Atlas matters, not because it changed our laws of motion, but because it reminded us we're part of a living galaxy, a place where everything drifts, everything connects, and everything, eventually, comes home somewhere. And if that realization keeps you awake a little longer tonight, staring up at the dark, that's fine. The stars have been waiting for us to notice the traffic. Let's tilt our ear now toward the hum beneath the data, the soft, recurring rhythm that makes even the most rational minds lean forward in the dark. Some began to notice a curious alignment, each interstellar visitor arriving slightly earlier than predicted by statistical models, as though part of a rhythm. Coincidence? Perhaps, but it made for sleepless nights at SETI headquarters. Patterns are humanity's favorite addiction. We see them in constellations, in coffee stains, in clouds, in chaos. We need them. And when scientists began plotting the arrival dates of Oumuamua, 2I Borisov, and 3I Atlas on the same temporal map, the dots didn't scatter, they began to hum. Not musically, of course, but statistically. A rhythm, not perfect, but unsettlingly regular. No one wanted to say it out loud, but you could feel the idea crackling behind closed conference doors. What if they're not random? At first, the supposed pattern looked trivial. The time gaps between discoveries were roughly decreasing. 8 years between Oumuamua's predicted path and its theoretical predecessor, 2 between Oumuamua and Borisov, 6 between Borisov and Atlas. Hardly enough to justify conspiracy or cosmic choreography. But when a few independent teams ran predictive simulations backward and forward, something strange emerged. The models kept placing potential interstellar arrivals along the same trend line, as though some quiet clock were ticking out arrivals every few years, nudging the galactic roulette wheel ever so slightly in our direction. Of course, the skeptics pounced. Statistics are like mirrors, one said. If you stare too long, you'll start seeing yourself. They were right. Pattern seeking can be dangerous. You can drown in coincidence, but still the alignment refused to behave like pure chance. Someone at SETI, half-jokingly, called it the metronome hypothesis, the idea that maybe, just maybe, these visitors weren't isolated events, but parts of a longer cycle, each fragment flung into the galaxy at intervals, like cosmic breadcrumbs dropped along a trajectory that leads, eventually, somewhere. It sounded like science fiction, of course, the kind of theory you'd whisper only after 3 espressos and a career's worth of tenure. But it wasn't impossible. Stellar systems interact all the time. Passing stars tug at comet clouds, causing waves of ejected debris. The rhythm could be gravitational, not intentional, a kind of galactic heartbeat echoing across millennia. And yet, the timing was eerie. SETI, the search for extraterrestrial intelligence, has seen its share of false alarms. Radio bursts that turn out to be microwaves, alien signals that turn out to be Wi-Fi. But this was different. It wasn't noise. It wasn't chatter. It was absence, repeating itself on schedule. The cosmos quietly dropping objects into our solar pond, each one arriving just ahead of expectation, as though obeying a rhythm older than us. You can imagine the late nights in that building, screens glowing, equations scrawled on whiteboards, someone quietly humming without realizing they're doing it. Outside, the desert cold. Inside, theories warming like coals. One researcher looked up from their laptop and said, "If there is a pattern, it's either mechanical or meaningful." Then, after a pause, and I'm not sure which one's scarier, to the public, of course, none of this leaked. Officially, 3i Atlas was just another data point, but in the back channels, encrypted emails, quiet Zoom calls between observatories, the whispers spread. The objects weren't arriving randomly. Their approach vectors were oddly distributed, their inclinations clustered in a way that seemed statistically biased toward the plane of our solar system. Coincidence? Sure, but 3 coincidences start to feel like choreography. A few dared to speculate. Perhaps these weren't independent bodies at all, but fragments of something larger, a single catastrophic event, a planet or structure that shattered long ago, sending its remains drifting through the galaxy in waves. If so, those waves would arrive in sequence, predictably spaced. That would explain the rhythm, a geological echo from a tragedy millions of years past. That theory, at least, was comforting. It made the universe sound sad instead of deliberate, because the alternative that someone sent them felt a little too cinematic for comfort. Still, the human brain, ever the pattern seeker, can't help itself. You, right now, are doing it too. 3 points, 3 arrivals. If there's a 4th, when will it come? What if we're already seeing it, faintly, mislabeled as a distant comet, waiting to reveal its identity? What if these aren't visitors, but signals written in motion language, measured in centuries instead of seconds? The more they looked, the more ambiguous it became. A few noticed that each visitor's orbital plane intersected roughly the same celestial coordinates, a region near the galactic apex, where the sun moves through the local cloud of stars. It could be coincidence, it could be geometry, or it could be design, the kind of alignment that happens when someone wants to ensure their message crosses the same receiver every time. SETI didn't issue a statement, of course. Officially, the pattern was dismissed as coincidence, the product of limited data and enthusiastic humans. Unofficially, the staff joked about keeping a calendar for the next one, because deep down, everyone knew the truth. Even a broken clock can keep cosmic time if the universe winds it just right. And that's what makes this whole story so quietly haunting. Whether the rhythm is real or imagined, it's already changed how we listen. Astronomers have begun watching the skies in anticipation, not reaction. They've stopped waiting for noise and started listening for silence that repeats. You, listening now, might find that thought strangely comforting, that across billions of kilometers, a handful of tiny fragments might be moving in time to a song we can barely hear. Whether it's gravity's lullaby or something else entirely, the effect is the same. We are no longer just observers of randomness. We are participants in rhythm, and somewhere in that rhythm, the next note is already on its way. Let's step back now, way back, until the scale of things starts to dissolve beneath your feet. To a human, 3i Atlas was a fleeting speck. To the galaxy, it was just another grain in an endless tide of matter. Yet for a few short weeks, all of Earth's telescopes turned toward that speck, and for a moment, the human species remembered how to wonder. There's something almost heartbreakingly brief about it, isn't there? Millions of years drifting through cold nothing, only to spend a few seconds sliding across one tiny blue planet's attention span. It's like the cosmos waving once through the window of time and vanishing before anyone could blink. From a geological perspective, our entire observation of 3I Atlas lasted less than an instant, a literal blink in the deep time of the universe. The object had traveled for eons, its path carved by chance and starlight, only to pass through the small, fragile cone of awareness we call civilization. For those weeks, the entire planet pointed its lenses upward, united not by fear or greed, but by curiosity. And that's the quiet miracle of moments like this. We so rarely agree on anything as a species, but give us a speck of mystery, and suddenly, everyone's craning their necks toward infinity. Imagine being part of that shared gaze, the late-night watchers in Chile, the graduate students in Arizona, the engineers at Mauna Loa, squinting through humidity and fatigue. The data scrolled, the graphs updated, and humanity, for all its chaos, was briefly synchronized to a single rhythm, the heartbeat of a rock that might not even be a rock. It's funny, isn't it? How something so ancient and indifferent could make us feel young again. The scale of it is dizzying. 3I Atlas may have spent tens of millions of years wandering between stars, epochs during which galaxies collided, species evolved, mountains rose and fell. Whole civilizations, perhaps on distant worlds, might have appeared and vanished in the time it took that object to drift from one system to the next. And then, for a fraction of a cosmic second, it brushed past ours. That's deep time. The kind of time that doesn't measure in seconds or centuries, but in silence. The kind that erases everything except motion. To the galaxy, our fascination with this passing fragment was probably as imperceptible as a dust mote flickering in sunlight. But for us, it meant everything. Because in that brief encounter, we were reminded of our place, not at the center of anything, but within it. There's humility in that realization. We live our lives on human scales, decades, jobs, relationships, days that begin and end. But the cosmos doesn't notice those rhythms. It breathes in aeons. A rock can take 1,000,000 years to turn once around a star. Light itself needs hundreds of millennia to cross a galactic arm. And yet, somehow, we caught one of those travelers mid-flight, pinned it for a heartbeat under our gaze, and said, "We see you, and maybe that's enough." Because, really, what else can we do? The universe doesn't offer closure. It offers glimpses. Every discovery is a conversation that ends too soon. Oumuamua, Borisov, Atlas, each one arriving, whispering something unintelligible, and leaving before we learn the language. Still, in that blink of time, something quietly profound happened. Humanity didn't just observe, it noticed itself noticing. We saw not only an object, but our own reflection in its passing, our restlessness, our curiosity, our urge to make meaning from the meaningless. There's a line one astronomer scribbled in the margins of his notebook after a sleepless observation night. "It's not the rock that matters, it's that we looked." And he's right. 3I Atlas could have been dust, metal, crystal, or sail, it doesn't matter. What matters is that for a few weeks, in a century otherwise drowning in noise, people paused. We pointed our instruments, our attention, and our collective awe towards something larger than ourselves. For those nights, the arguments stopped. The funding worries, the deadlines, the earthly absurdities all faded beneath the soft glow of a wandering light that didn't even know we existed. You, lying in bed, listening now, might feel the same hush, that strange ache that comes when you realize how impossibly small and impossibly lucky we are to even see anything at all. Because the truth is, We will never know where 3I Atlas came from, or what it truly was. The data will stay incomplete, the models inconclusive, but in a way, that's perfect. Mystery keeps the engine of wonder running. Certainty would stop it cold. In 100 years, its name will fade into archives. In 1,000, its orbit will be forgotten. But that feeling, that flash of awe, will live on in the next thing we find, and the next, and the next. That's how wonder works. It doesn't stay, it visits. Like all travelers, it arrives, reminds us who we are, and then slips quietly back into the dark. Let's return now to the chalkboards, to the equations, and their quiet defiance. Because when science hits a wall, it doesn't break, it echoes. When the models failed to match observation, one physicist asked a different question. What if the discrepancy wasn't in the math, but in the assumption that the object was inert? What if it could respond to sunlight in ways we hadn't imagined? It was a heretical thought, at least in the polite corridors of astrophysics. Objects don't respond, they obey. They absorb photons, reflect them, heat up, cool down, all within the well-behaved laws of thermodynamics. But this idea wasn't about breaking physics. It was about expanding its vocabulary. The physicist and experimentalist from Kyoto began modeling not the light, but the conversation between light and surface. What if 3I Atlas didn't simply endure the solar radiation, but used it? What if its structure could subtly shift, its material properties changing in real time under illumination, like self-adjusting glass? In simpler terms, what if the object was alive, but not biologically? The concept wasn't biological at all, but mechanical, an active material, something that changes its physical state in response to energy input. On Earth, we make such materials all the time. Shape memory alloys that bend when heated, smart polymers that contract under light. Nature does it too, plants tilting toward the sun, bacteria swimming toward nutrients. Why couldn't matter itself evolve similar reflexes in the vacuum of space? The physicist proposed a startling model. In it, 3I Atlas wasn't passive debris. It was a system, not a machine, not a mind, but a kind of echoing surface. Light didn't just bounce off. It set off tiny, resonant ripples through the layers of the object, altering how the next wave of photons reflected back. In essence, the object remembered light. That's where the term echo came from. The idea that sunlight itself could bounce differently depending on what came before, as if 3I Atlas was playing a slow-motion duet with the Sunday. The equations described feedback, not just reflection. The math became recursive light hitting the surface responding, the new reflection modifying the next input. It was stable but unpredictable, like a musical instrument constantly tuning itself. When the physicist ran the simulation, something eerie happened. The model produced a pattern of reflectance, nearly identical to what telescopes had recorded. The strange fluctuations, the ones everyone called noise, weren't noise at all. They were the rhythm of interaction. In the simulation, the pattern even pulsed in intervals, faintly mimicking the spin rate, almost like heartbeats syncing with breath. The Kyoto group sent their findings quietly to several observatories. Most dismissed it. Elegant, they said, but fanciful. And yet, privately, a few researchers couldn't stop staring at the graphs at how neatly the chaos resolved once you let the material respond. Imagine what that means. A natural rock, perhaps born from a shattered world, made of compounds that evolved under alien suns to behave like memory foam for light. Each photon that strikes it doesn't just reflect, it reshapes the object's skin, ever so slightly, altering its next interaction. Over millions of years, That feedback becomes choreography. The surface teaches itself to move. You, listening now, can almost picture it a shard of something ancient, tumbling in slow grace, shimmering like it's breathing sunlight, not alive, not intelligent, but aware in a way that only physics could be, responsive, rhythmic, reciprocal. It makes you wonder how many other rocks out there are quietly singing to the light that touches them, whispering back across the vacuum. This theory, the echo hypothesis, as it came to be nicknamed, was never formally published. The physicist hesitated, worried it would sound too poetic. But among those who read the draft, it became a kind of legend, a footnote in late-night coffee conversations, a secret door in the imagination of scientists too curious to sleep. One astronomer in Chile described it beautifully. It's as if the universe built wind chimes, and light is the wind. The idea didn't claim intention or design. It simply suggested that matter could be more dynamic than we thought, that the boundary between physics and behavior wasn't as sharp as we like to believe. And maybe that's the real lesson of 3I Atlas. Not that it was an alien artifact, or a sail, or a probe, but that the cosmos itself experiments. It builds, tests, erodes, remembers. Over billions of years, the universe learns what works through gravity, through light, through repetition. If that's true, then 3I Atlas wasn't strange at all. It was just evidence that the galaxy is full of self-tuning instruments, still ringing from the creation of stars long gone. You can almost hear it if you're quiet enough. The faint hum of light, striking matter, bouncing, learning, repeating. The echo that never stops. Maybe the physicist was wrong. Let's exhale for a moment, because before mystery becomes mythology, science always tries one last thing: reason. To be fair, science offered plenty of non-mystical possibilities. Volatile jets, invisible to our instruments, fractal dust layers, hollow structures from ancient collisions, each plausible, none perfect, like puzzle pieces that almost fit, but never quite click. And so began the great sorting, that ritual dance, where astronomers try to wrangle wonder back into physics. The first camp went straight for comets. Maybe, they argued, 3I Atlas was venting gas just too faint for us to see. Even a whisper of sublimating ice could produce thrust, explaining its odd acceleration. Problem solved. Except there was no gas, no coma, no tail, no spectral fingerprint of water, methane, carbon dioxide, anything. The object was as dry as math homework. Next came the dust layer theory. Perhaps the surface was coated in micrograins that scattered sunlight unevenly, creating the illusion of acceleration. It made sense until someone noticed the acceleration changed direction slightly with every orbit simulation. Dust doesn't improvise. Then came the hollow shell, model a crowd favorite among the romantically pragmatic. Imagine an asteroid blasted apart by ancient impact, leaving a fragile husk of rock. That hollow structure could behave strangely under radiation pressure, wobbling like a paper lantern in solar wind. Elegant, almost beautiful. But again, it didn't fit. A hollow body that fragile shouldn't have survived the violent entry past the Sunday. It would have cracked, scattered, left debris. Instead, 3I Atlas left nothing but confusion. One particularly bold theorist suggested fractal geometry, that the object's surface was a self-similar lattice of microscopic voids, producing non-linear reflectance, a rock shaped like math itself. It sounded brilliant, until someone actually modeled it and realized the resulting object would have the density of styrofoam and the lifespan of a soap bubble. Every new explanation worked, until it didn't. That's the thing about natural explanations. They're like duct tape, reliable, respectable, and almost always temporary. When the universe hands you something too strange, the scientific instinct is to throw models at it until one sticks long enough to be published. But 3i Atlas refused to stay taped together. Still, no one wanted to reach for the exotic. That's the unwritten rule of academia. When confronted with the unknown, assume incompetence first. Faulty data, bad calibration, human error, anything but new physics, anything but purpose. So the search for natural causes became almost devotional. Teams in Prague, Hawaii, and Japan independently simulated gas jets, non-uniform heating, spin-stabilized fragments, even outgassing triggered by cosmic rays. Each model captured one behavior, but broke another. Like a cosmic whack, a mole. Fix the spin, ruin the glow, explain the light curve, lose the acceleration. It was maddening and kind of beautiful, because in those late nights of failure, something quietly human happened. People who'd spent their lives cataloging rocks started writing poetry in their emails. "It's the universe trolling us," one joked. "Maybe it's testing whether we deserve better telescopes." A researcher in Chile tried humor to cope. "We've ruled out aliens, gods, and sensible physics. What's left?" A reply came minutes later. Hope, but hope too needed grounding. One possible savior appeared in the form of exotic chemistry compounds that behave unpredictably under extreme temperature shifts. Perhaps 3i Atlas contained layers of minerals that expanded differently in sunlight, creating microscopic thrust. That could explain the acceleration, maybe even the spectral oddities. Finally, a theory with legs. Thin, trembling legs, but legs nonetheless. Yet again, it broke on contact with math. The observed acceleration was simply too smooth, too continuous. Natural forces tend to stutter. This one purred. It was around this time that a few scientists, the quiet rebels, began to whisper the forbidden phrase again. Non-gravitational intelligence. Not life, not civilization, but behavior that imitates decision. Of course, they didn't publish that thought. You can't write, "Maybe it's thinking," in a peer-reviewed journal. But in midnight messages, the question pulsed anyway. What if our natural explanations are too small? You, listening now, can feel that tension, the tug of war between comfort and curiosity. We want the world to be knowable, but the universe insists on being interesting instead. Maybe all those theories are right in pieces. Maybe 3i Atlas really was a hollow, fractal, chemically erratic comet fragment, doing a flawless impression of intention. Or maybe it was something nature hasn't invented yet, a form of order we haven't met. Because that's the secret truth of science. Natural is just another word for understood. Everything's supernatural until you figure it out. So the search continues. New models, new equations, new midnight arguments, 1,000 natural explanations, all slightly wrong, orbiting the one truth that refuses to speak. And perhaps that's fine, because in the space between certainty and wonder, humanity does its best thinking. Maybe the universe doesn't owe us perfect answers. Maybe it just wants us to keep asking better questions. Let's follow the motion now, not the light, not the shape, but the rhythm hidden in the spin itself. Because when you watch something move, you're really watching it think. One odd detail: the object's tumbling motion slowed down, not sped up as it left the solar system. Friction couldn't explain it. But if it had internal structure, hollow chambers, perhaps the physics changed. It was as though something inside was shifting, balancing. That detail didn't make headlines, But among the scientists tracking 3I Atlas, it was the whisper that wouldn't fade. Space, after all, is frictionless. Once you start spinning, you keep spinning, unless something or someone tells you to stop. The initial assumption was that sunlight caused the slowdown. Radiation pressure could, in theory, produce torque on a thin object, like a sail catching starlight. But the effect was too precise, too gradual. A comet might wobble, an asteroid might tumble. This was more like correction, like a dancer adjusting her balance mid-turn. One researcher in Prague called it momentum management. She didn't mean it literally, but the phrase stuck, because that's what it looked like, a subtle tuning, as if 3I Atlas was listening to itself spin and didn't like the tempo. In physics, rotation is sacred. It tells you everything: mass, structure, density, even history. You can tell when an object is solid, fractured, or fluid inside, just by how it turns. But 3I Atlas broke the rules. Instead of spinning down through chaotic jitter, it eased itself into a slower, smoother rhythm, like a pendulum learning grace. At first, astronomers blamed measurement error. They recalibrated their photometry. Nothing changed. They double-checked the timestamps, all consistent. The deceleration was real. Now, imagine that for a moment. An object the size of a small building, alone in space, slowing its spin deliberately. There's something eerie about that, like watching a leaf drift upward, or hearing a heartbeat in stone. One team proposed an internal explanation. Maybe it wasn't a solid rock, but a composite layers of different materials shifting under centrifugal stress. Imagine an egg yolk sloshing inside a shell. That motion could absorb rotational energy, acting like a natural damper. It made sense, but not enough. The change in rotation rate was too controlled, too linear, as though following a feedback loop. Feedback loops, of course, are the language of machines. That's when the theories started to sound like confessions. Maybe 3I Atlas wasn't controlling itself. Maybe it was reacting. As it passed through the inner solar system, it absorbed radiation, heat, and magnetic fields. Those forces could have induced internal expansion, even piezoelectric effects in metallic structures. That expansion could shift balance points, redistributing angular momentum, still natural, still explainable, just elegant, too elegant. It was almost poetic, a rock using sunlight to rewrite its own motion. But that interpretation, the reactive model, carried implications that made even the boldest theorists squirm. Because if it could adjust its spin, it could store energy. And if it could store energy, it could in theory release it. That's when someone at SETI joked, maybe it's spelling something out. The words were met with nervous laughter. But someone else, quietly curious, decided to check. They converted the rotation rate data into audio frequencies and sped them up. What they heard wasn't music, or pattern, or even message, just a long, rhythmic pulse. But once you've asked the question, you can't unask it. Was the pulse random, or was it a message written in motion, like Morse code encoded in a dance? To most, that idea was ridiculous. Physics doesn't flirt with intention, but every mystery has its romantics, and they noticed something stranger still. The rate of rotational slowdown wasn't perfectly smooth. It came in steps, tiny plateaus, evenly spaced, like a heartbeat missing every fourth beat. It wasn't proof of anything, but it was enough to turn a few late nights into longer ones. There's an old saying in orbital mechanics: motion remembers. Every change, every nudge, every torque tells a story about cause and consequence. And 3I Atlas's motion, its gentle, deliberate slowing, told a story that didn't quite fit any category we knew. Maybe it really was just physics' internal redistribution, complex composition, a coincidence of mass and geometry. But maybe, just maybe, it was something more subtle. A kind of echo, not of intelligence, but of design. A whisper left behind by a process that knew how to balance itself long after its maker was gone. You can almost picture it, a hollow relic adrift for millions of years, responding to sunlight and spin like an ancient instrument, still tuned to a forgotten frequency. Its movement a melody too slow for us to hear, too vast for us to comprehend. And if that's true, if motion itself can carry memory, then maybe the universe is full of messages we've mistaken for mechanics. Because sometimes, the way a thing moves is the story it's trying to tell. Let's turn the telescope back around for a moment, not toward the sky, but toward us. Because as always, the data was less confusing than the people. Some scientists doubled down on natural explanations. Others whispered of engineered origins. And in between, a tired graduate student somewhere spilled coffee on the model file and muttered, "Maybe it's both." That's the thing about science, it's not a machine. It's a mood, a collective human attempt to make sense of things, vastly older, colder, and less emotional than we are. And when an anomaly like 3I Atlas sails through our solar system, it doesn't just test our instruments, it tests our personalities. For every calm, careful analyst, there's a visionary with conspiracy glitter in their eyes. For every cautious skeptic, there's someone secretly hoping for the headline, "We're not alone." The truth is, the boundary between logic and longing is thinner than we like to admit, maybe about as thin as whatever material 3I Atlas was made of. You could see it play out in real time. The debates on astronomy forums, the furious threads of peer reviewers, the polite but pointed conference questions that begin with "just to clarify" and end with the speaker silently questioning their career choices. In Hawaii, a research assistant built a 3D model of the object and accidentally made it look like a tortilla. Her professor told her to increase fidelity, so she turned it into a disc. Suddenly, every internet commenter decided it was a UFO. By the next morning, the model was viral, her inbox was in flames, and she had to publicly clarify that she didn't mean saucer. The Rahmans are very bind of views. That's the human factor in action. The cosmos gives us data, and we give it drama. And yet, that chaos is also what makes discovery beautiful. Because science isn't sterile. It's caffeine-fueled, ego-driven, curiosity-soaked chaos in lab coats. It's people arguing at 2 a.m. over numbers that might mean everything or nothing. It's that fragile mixture of pride and doubt that keeps us crawling toward truth through a fog of uncertainty. At one observatory, an astrophysicist named Lena tried to settle the debate with humor. During a live stream, she said, "If it's aliens, I hope they like spreadsheets." The chat exploded, donations spiked, and her boss sighed so loudly it echoed through the dome. But the line stuck, because maybe that's exactly what humanity would send into space. Not monuments, not messages, but spreadsheets. Still, the tension ran deep. Those who believed in natural explanations accused the others of romanticizing the unknown. Those open to stranger possibilities accused the skeptics of arrogance. Each side saw itself as the reasonable one, which, of course, is how you know it's a human argument. Behind the scenes, the politics were no less cosmic. Grant proposals shifted. Research priorities changed. Interstellar object went from obscure phrase to funding keyword overnight. Departments that once competed now collaborated or pretended to, because mystery, as it turns out, is excellent for budgets. You can almost picture it, scientists smiling for press photos, holding mugs that say, "I need space," all while silently thinking, "I don't trust anyone's data but my own." And amid all of this, the graduate students, the sleep-deprived, unsung backbone of discovery, kept the whole operation from collapsing. They calibrated instruments, corrected typos, coded new filters, and occasionally fell asleep in chairs, dreaming of datasets that never stopped changing. One wrote in her lab notebook, "I don't know what this thing is, but I'm weirdly fond of it." That fondness is the most honest reaction of all, because to be human is to care about things that don't care. Back stars, comets, algorithms, each other. Eventually, the papers came out, each one slightly different, each claiming confidence in its interpretation. Some framed 3I Atlas as anomalous but natural, others as possibly artificial. One even coined a new term, technically ambiguous object, which is academic language for "we give up politely." And yet, through all the equations, simulations, and spilled coffee, something deeper emerged, a kind of quiet humility, because in trying to define 3I Atlas, scientists found themselves staring into a mirror, the object's contradictions stable yet chaotic, inert yet reactive, mirrored our own. Humanity, too, is an anomaly, emotional yet logical, curious yet terrified, desperate for meaning yet built from accidents. Maybe the reason 3I Atlas fascinated us so much is because, for once, the universe seemed to be behaving just like we do, mysteriously, inconsistently, beautifully. You, listening now, might smile at that thought. Somewhere out there, a cold, silent fragment of the cosmos drifted past, and for a few weeks, it made us remember what it feels like to be alive, to argue, to wonder, to doubt, to dream, because sometimes the hardest part of understanding the universe isn't the math, it's the mirror. Let's turn the question around, just for a moment. We've spent all this time wondering what 3I Atlas was, but what if, out there, someone is wondering the same thing about us? Think of Voyager, our own interstellar emissary, still drifting outward. In a million years, it might pass another star system, invisible and silent. To the beings there, it would look like an anomaly too, an artificial speck mistaken for rock. That thought lingers, doesn't it? Because Voyager isn't just a probe, it's a bottled message tossed into an ocean of stars. It carries our music, our languages, the sound of thunder and laughter, the heartbeat of a planet that wanted to be known. And yet, in cosmic terms, it's already fading into invisibility. Its golden record will outlive every continent we know, but it won't glow, it won't hum, it won't announce itself. It'll just drift quiet, cold, and mysterious. To us, it's a miracle. To someone else, it might look like an oddly symmetrical rock, a metallic curiosity, a 3I Atlas in their sky. And that's the humbling symmetry of it all. We are both the observers and the anomalies. We send our machines into the dark, and one day, someone else will puzzle over their motion, their shine, their unexplainable steadiness. They'll debate in whatever language they use, natural or engineered, coincidence or intent. They'll draw graphs, argue in conferences, spill alien coffee on alien data sheets, and someone will mutter, "Maybe it's both." We are doing now exactly what they will do later, projecting our own confusion onto the unknown. It's a cosmic mirror, tilted ever so slightly so that we can glimpse our reflection in the stars. Voyager, Pioneer, New Horizons, all of them are our fingerprints smeared across the cosmic window. We call them emissaries, but really, they're echoes of longing. We didn't send them because we expected an answer. We sent them because silence is unbearable. If you think about it, maybe that's what 3i Atlas was too. Not an arrival, but a reminder, a reflection of what it feels like to reach into the void and hope something reaches back. Because deep down, every civilization, no matter how advanced, eventually learns the same truth. You can't keep still. You have to send something out, even if it never comes home. Now imagine the reverse. Somewhere, far beyond the rim of our understanding, another world could have done the same. They might have built something, launched it, forgotten it, and moved on. Eons later, their creation wanders into our sky, and we, with our telescopes and tempers and theories, name it 3i Atlas. And the beauty of it is, that might be exactly what we are witnessing. Not invasion, not intention, just the cosmic archaeology of curiosity, relics of explorers who, like us, couldn't help but ask what lies beyond. You, listening now, might glance at the ceiling or the stars, if you're lucky enough to see them. Somewhere out there, Voyager is still humming through the dark, carrying greetings from beings who laugh, who build, who spill things, who dream. It's the same human energy that discovered 3i Atlas, the refusal to let mystery be lonely. In time, our probes will fade, their power will die, and their surfaces will weather into anonymity. They'll become debris indistinguishable from dust. And yet, in that decay, they'll be reborn as myths for someone else. A story waiting to be rediscovered by eyes that don't know what NASA means. Think about that. Someday, some distant intelligence might pick up Voyager's faint metallic echo and ask the same question we asked: who made this? And maybe, just maybe, they'll run their equivalent of spectroscopy, find traces of gold and copper, and argue over whether nature could have arranged them that way. One will insist it's natural, another will whisper it's deliberate, and a third, perhaps over a cup of something warm, will say, maybe it's both. The debate will go on, looping endlessly, generation after generation, and that's the point. Wonder doesn't need resolution. It only needs participants. 3i Atlas, Voyager, whatever comes next, they're all pieces of the same conversation, conducted across light years and millennia. It's not about finding aliens or proving intelligence. It's about continuity, the echo of curiosity, bouncing back and forth through the dark. Maybe the universe doesn't separate the natural from the artificial at all. Maybe it just calls everything alive enough to move. And when you think of it like that, Voyager isn't leaving us behind. It's teaching us how to be found by others, by time, by the infinite patience of the cosmos. So perhaps, one day, when someone else spots it glinting in their sky and names it something poetic in their own tongue, they'll feel exactly what we felt, watching 3i Atlas past that sudden, shivering awareness that the universe remembers us, even if it doesn't know our name. Let's take one last look upward, not at the object itself now, but at the name that found it. The irony is that Atlas, the survey that found it, was named for a titan condemned to hold up the sky. Fitting, then, that its greatest discovery might be something holding up our understanding of what's natural. Every anomaly is, in a sense, a mirror. There's something poetically cruel about names, isn't there? We name machines after myths, and myths after the fears we can't define. The Atlas survey, automated terrestrial and lunar asteroid survey, was built to watch the heavens for danger, rogue rocks, impact threats, cosmic trespassers. Its job was to warn us, not to inspire us. Yet somehow, it did both. It held up the sky, just like its mythic namesake, only instead of shoulders, it used silicon and code. And then, through those digital eyes, It saw something no one expected. 3I Atlas, the Titan's namesake, finding a mystery strong enough to lift the weight of certainty itself. You almost have to laugh at the symmetry. A human-built machine staring into the heavens finds something so odd that it bends the very concept of natural. It's as if the myth came full circle. The Titan still holding up the sky, but now holding up our doubt instead. The discovery forced a quiet reckoning. What is natural, after all? A spiral galaxy is natural, but so is a heartbeat, a virus, a volcano, a violin, each born from different forms of complexity. The universe doesn't draw neat boundaries between chaos and intention. Only we do. Atlas, the machine, not the Titan, doesn't care about those distinctions. It just records light. A faint streak, a flicker, a number in a spreadsheet. But behind those lines of data sits the most human act imaginable: interpretation. Someone looks at the pattern and says, "Wait, that's not right." And from that small moment of doubt, entire galaxies of meaning unfold. That's what holding up the sky means now. Not carrying it on our backs, but questioning it. The Titan's punishment has become our privilege. We inherited the burden of curiosity, the endless, exhausting need to keep looking up. You can almost picture Atlas humming away quietly on a Hawaiian night, its lenses staring through humid air, scanning for motion. It doesn't dream, it doesn't hope, but the people running it do. They sit in small rooms lit by screens, watching blips of light crawl across graphs, unaware that they're continuing one of humanity's oldest myths. Atlas once held the heavens, now we hold the data, and yet, somehow, the myth remains. When 3I Atlas appeared, the name clicked instantly, not because it was formal, but because it fit. It felt inevitable. A discovery that reminded us, once again, that even the most advanced tools in the world are still instruments of wonder. Every anomaly is a mirror, yes, but not just of the universe. Of us, the questions we ask, the limits we reach, the biases we carry. Natural becomes whatever we're ready to accept, and unnatural becomes whatever scares us. But 3I Atlas didn't scare. It intrigued. It teased. It laughed, perhaps, in that slow, cosmic way that only ancient things can. When the data came in, someone reportedly said, "It's not just holding up the sky, it's holding up our definition of it." And maybe that's the real story. Every mystery we find, every anomaly that refuses to behave, stretches our understanding, forces us to lift a little more of that sky ourselves. Because the truth is, knowledge is heavy, certainty is heavier, and curiosity, the force that keeps lifting it all, is the only thing that keeps it from crushing us. Maybe that's why we build things like Atlas, not just to find what's out there, but to remind ourselves that there's still an out there to find. You, lying there now, might close your eyes and imagine the night sky above Hawaii, vast, deep, indifferent. The telescope hums, the earth turns. Somewhere, a new streak of light crosses the screen. Maybe it's another fragment, another anomaly, another whisper from the unknown. Maybe it's nothing, but the act of looking, that's everything. In Greek myth, Atlas was finally relieved of his burden when Perseus tricked him into seeing Medusa's head. He turned to stone still, but free. Humanity, on the other hand, keeps holding the sky willingly. We can't stop. We don't want to, because for all the exhaustion, the sleepless nights, the questions without answers, this is what we do best. We hold up wonder. We balance the weight of knowing and not knowing. And in that balance, for just a moment, we find grace. So maybe the Titan isn't punished anymore. Maybe, through our telescopes, through Atlas and Oumuamua and Three-Eye Atlas, he's finally found his purpose not to bear the heavens, but to help us lift our gaze toward them. And as long as we keep doing that, the sky will never fall. Let's come back to the beginning, or maybe to the place where beginnings and endings quietly trade places. Maybe the anomaly isn't the object itself. Maybe it's us, our assumption that we've already seen all the ways the universe can build, move, and shine. 3-Eye Atlas may just be the universe's way of reminding us that mystery is not a glitch in the data. It's the feature that keeps us looking up. We like to think of anomalies as problems misbehaving equations, outliers that spoil the graph. But sometimes, they're not errors at all. They're the punctuation marks at the end of our certainty. And Three-Eye Atlas, in all its quiet defiance, might just be the cosmic equivalent of a question mark. That's what science really is. A love letter to the unknown, written in equations that we keep rewriting. Every generation thinks it's close to understanding everything, and every anomaly arrives to remind us that we've only built the scaffolding, not the cathedral. You can almost imagine the universe smiling a little when Three-Eye Atlas appeared, a faint streak of light, a gentle nudge that whispered, "You're adorable when you're confident." Because every time we claim the map is complete, something wanders in from the margins, carrying the smell of new questions. Maybe the real message wasn't hidden in its motion or its shape or its glow. Maybe it was in the timing. It arrived precisely when humanity needed a reminder that discovery isn't finished, that wonder hasn't run out. We live in an age where we can simulate worlds, photograph black holes, and predict quantum behavior down to absurd decimals. But then a single speck of reflected sunlight, an object smaller than a skyscraper, comes drifting by, and suddenly we're children again, standing barefoot in the grass, pointing upward, asking, "What's that?" There is actually minute. It's humbling, beautifully so, because mystery, at its core, is mercy. It saves us from arrogance. It keeps the universe vast enough for hope. If we ever reached a point where everything made sense, where no data point ever misbehaved, it wouldn't be paradise. It would be a museum. Perfect, still, dead. Instead, we live in a universe that stutters and surprises, that hides things behind curtains of probability and timing, a place that insists we keep showing up, telescope in hand, ready to be wrong again. And maybe that's the point. Three-Eye Atlas didn't change the laws of physics. It changed our relationship with them. It reminded us that laws are descriptions, not commandments, that nature doesn't owe us simplicity, that our greatest instrument isn't the telescope or the computer, but curiosity itself. Every scientist who stared at those residuals, every student who adjusted a calibration knob, every observer who blinked against dawn light and thought, it doesn't add up. They were participating in something ancient, the same impulse that once made cave dwellers trace stars on rock walls, the same hunger that built observatories on mountaintops and launched probes into the dark. Maybe the anomaly is not a visitor, but a mirror showing us how we respond when the universe whispers, "Try again." And in that reflection, we look almost divine, not because we know everything, but because we keep asking anyway. You, listening now, might feel that in your chest that small, defiant flicker of wonder that refuses to grow old. That's the same spark that built telescopes, wrote equations, and named the stars. It's what makes you human. It's what makes you infinite, at least in intention. So, what does the anomaly really mean? It means the story isn't over. It means the sky still holds secrets. It means that every unanswered question is proof that we're still alive enough to ask. Perhaps Three-Eye Atlas wasn't trying to tell us anything. Perhaps it simply was. and we were the ones who turned its silence into meaning, because that's what we do. We find poetry in physics, faces in shadows, stories in stars. Maybe that's not arrogance. Maybe that's the universe learning to know itself, piece by curious piece, through us. Because if you zoom out far enough, there are no observers, and no observed, only one grand act of noticing, echoing back and forth through time. And so, the final truth of the anomaly might be this: the universe isn't a solved equation, it's a living question. And as long as something like 3i Atlas can pass through our sky and make us look up again confused, awestruck, laughing, afraid, then the cosmos is still doing its job. It's reminding us that wonder is not an accident. It's the design,